All right, everybody. Should be live, up and running now. Please let me know if you can hear me and see me. I know this is a little bit different. Usually I stream at nighttime. But please let me know if you can hear me and can see me. So definitely appreciate that. So got some great things going on. So very blessed and very happy to be with all of you this beautiful early morning. So again, please let me know if you can hear me and can see me because this is going to be a very great chat lined up. Very great other session lined up today. So let me see. Let me see if let me look at my audio then. It looks like what does it say here? It looks like is the audio off a little bit? Let me know. And I can fix that. It's an echo. Okay. Let me see here then. All right, give me 1 second to fix that, and I will be right back. Oh, hey, let me know how the audio is right now, please. Let me know how that sounds. Please let me know if there's an echo still or if that has been fixed. Okay, no echo. So we should be pretty good if we don't have an echo now. It's my first time streaming to 4 different platforms. So today, streaming to uh, Facebook, YouTube, Kick, and Twitch. So starting to branch out. So I appreciate that. Appreciate everybody there. But again, if there are any audio issues, let me know again if there aren't any audio issues or there aren't any um, relative feedback issues. Um, so yes. So let me know on that. Give it another couple minutes here. I know it's early, so give time for people to wake up and to get rolling in here. So definitely appreciate that. So definitely looking forward to getting people in here. So righty. Looks like we got Nessie in here. Looks like we got my beautiful wife, Allison, in here. And again, please let me know have any if you have any echo still going on or anything else like that. But it should be fixed. So let me know if the audio sounds good now. So again, yes, please let me know if the audio sounds good. Thank you, Nessie, for being here. Thank you, everybody who is in here right now. I know it's early here in the U.S. It's only 9:25 in the morning here. Um, so again, let me know if the audio is good. So definitely need to know that. Okay. Looks like we're good. Looks like we're good. Looks like we are good here. So all right. Thank you, Nessie, so much for that. Again, please, if you can hear me and if it is all good, please let me know that the audio is all good, please. Okay. Nessie says good, and my wife says good. Okay, awesome. So, all right. And again, this is new um um foray into multi-streaming. So give me a little grace here, please, as I get acclimated with the other platforms as well. Looks like I am live streaming currently to Facebook, currently live streaming to Twitch, and currently live streaming to Kick as well. So please follow me on Twitch. Please follow me on Facebook, and please follow me on Kick as well. Definitely appreciate that. Starting to foray and go in down the path of multi-streaming to reach more people. So yes, Nessie, I am on Kick. And if you go to um, my profile on YouTube, if you look at the links on my profile on YouTube, you can click on my Kick link and please subscribe there as well. So, live on Kick, live on Twitch, live on YouTube, and live on Facebook. So, again, this is a new uh, dive into multi streaming. So again, please bear with me. Give me a little bit of grace as I get acclimated and make sure that all of that is up and running and everything else. So very thankful for that, and thank you. Um, so thank you all for that. I definitely appreciate all of that. So we will get started here in a few minutes, uh, and we will learn about a lot about tornadoes, and so so definitely want to touch base on that. Nessie says bit of a delay on YouTube. Kick is quicker, so okay. All right. Let me see if I can fix that delay, possibly. Uh, Change that up to. Okay, got that. Let me see if that changes anything. Uh, don't know if that's going to help with the YouTube delay a little bit, but besides that, hopefully that fixed a little bit of that. So when it comes to that, so take a look here just to make sure. So just give me 1 second here as well. Let's go to make sure. Okay. Okay, so we should be good. So, okay. All right. We should be good now. It's all taking on more CPU usage and things of that nature. So again, before I get started here, please let me know if the video feed is good and the sound feedback is good, and that you guys are not having any echo issues or any sound issues. And then we will jump in to tornadoes. Okay, Nessie says all good. Awesome. Appreciate that. So very good on that. All right. So, alrighty. And if you noticed, I put a new graphics up, new overlay here for the United States that gives us, lets us know any type of warnings and severe watches. So that is down here, as you will see down here now, where it has the where it says it has a flood warning and things of that like that. So that is a new overlay to just help people and individuals who can see warnings and things of that nature. So, all right. So very thankful. Like I said, I know this is a little bit different. Again, this is trying it out in the morning with again multi-streaming. Doesn't mean that I won't be streaming at night as well. Just means trying something different here because I really wanted to get to see how the multi-streaming is set up and how it's going. So this is again, it's all a learning process, and it is going to be very great. So again, live on Twitch, live on YouTube, live on Facebook, and live on Kick. So thank you guys again so much for being here. Thank you so much for joining in. And again, if there are any issues with the stream, please let me know, and I will continue to work on that in the background. So as we know, sometimes technology does not like to work with us sometimes. So, but nonetheless, very thankful that you guys are here. Very thankful for all of that. Thankful for all of you, and just very, very, just very gracious. So, but yeah. So I am about to get started here. So let's break into the topic. So, it's a fun topic. It's a great topic. Hopefully, it's a topic that you guys might already know a lot about, but you might learn some more information and understand from Tornadogenesis and just what actually defines a tornado. Some fun, cool facts, things of that nature. So, just very thankful for that. Very blessed for that. So, got some cool stuff lined up. everything from Tornadogenesis, like I said, to some fun facts and things of that nature that will help you, hopefully, learn more about tornadoes. So, with that, any more said, and without further ado, let's jump right in. And before I do that, obviously, first of all, just like always, I always have to give thanks and my just being grateful to my Lord and Savior, Jesus Christ, for helping me, for guiding me, for blessing me, for giving me this opportunity. So thank you, obviously, to my Lord and Savior, because without Him, none of this is possible. So, as always, just a great, um, just so thankful, so blessed, and so grateful for the Lord's blessing and for allowing me to do something like this. So, again, very, very blessed to do this. So, thank you guys so much. And so let's dive into what is a tornado, tornadogenesis, kind of the things that we want to be looking for. We'll touch on the EF scale. We will touch on again just things to really be looking for out there when it comes to tornadoes. And so again, great topic. Here we go. So, what is a tornado? So, it's $100 million question, right? So, a tornado is a narrow, violently rotating column of air that extends from a thunderstorm to the ground. So again, let me be very clear on this. A tornado is a narrow, violently rotating column of air that extends from a thunderstorm to the ground. So, to be absolutely clear, it has to be in contact with the ground. It cannot be above the ground. It cannot be 1 inch above the ground. It cannot be 1 centimeter above the ground. It has to be in contact with the ground in order to be definitively or as defined as a tornado. So, again, it says it right in the very first sentence. It has to be in contact with the ground or be on the ground in order for it to be defined as a tornado. So that's where a lot of times people get it wrong at. They will think that it can be they will think that it just would be like a funnel cloud or things of that nature. But no, a funnel cloud is not a tornado. So a tornado has to be in contact with the ground when it comes to that. So moving on. So remember, it has to be extending from a thunderstorm and in contact with the ground. And we'll get to touch a little bit more on that, a little more in depth on that here in a little bit. And so, because wind is invisible, it is hard to see a tornado unless it forms a condensation funnel, which is what we see coming down out of the cloud. That's a condensation funnel. Because it is made up of water droplets, dust, and debris. So that's when we get the visual on that tornado. Without water droplets, without dust or debris being kicked up and pushed around, we would not have any visibility on that tornado. So again, condensation is what gives us that visibility into the tornado. So tornadoes can be among the most violent phenomena of all atmospheric storms we experience. Yes, they are. And I will give you guys and teach you guys an acronym on how tornadogenesis and the things that are needed uh, that play into Tornadogenesis, and it would be very helpful. I hope for you guys. So again, that's what that it is. Just the basic definition of what a tornado is. It is a narrow, violently rotating column of air that extends from a thunderstorm to the ground. So again, it has to be on the ground. So very good for that. So yeah, so it has to do that. And again, a lot of times, it's the only time that we see it is because of the condensation made up of, again, of water droplets, dust, and or debris. So very great stuff. So very thankful again for all of you who are in here on this beautiful morning. So appreciate that. So moving along, where do tornadoes occur? Well, tornadoes can occur anywhere that the conditions are fair, or that the conditions are right, that the all the conditions come together. So it's really a broad, where they can happen at is anywhere that the conditions come together to create a tornado. So, but nonetheless, tornadoes occur in many parts of the world, including Australia, Europe, Africa, Asia, and South America. Even New Zealand reports about 20 tornadoes each year. I was not aware of that at all, because if you look at New Zealand on a map, that is way, 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 I believe, south of the equator. So that's it's pretty much close to Antarctica, so not very far off from that. So I was not aware of that. And then two of the highest concentrations of tornadoes outside the U.S. are Argentina and Bangladesh. So show of hands in here, who knew about Argentina and who knew about Bangladesh? So, and so great. So let me know if you knew about those two hotspots. And it looks like Nessie says UK has around 30 a year approximately. So 30 for, thank you, Nessie, for that great information. Appreciate that very much. Very awesome of you to provide that. Thank you. So if you look at that, if you look at where the UK's at on a map, and you look at to where New Zealand is at on the map, very far, far apart. One in the northern hemisphere, one in the southern hemisphere, and one basically gets about 10 more than the other. So if you look again, so Argentina and Bangladesh are big time outside of the U.S. is another hot spot. Although the U.S. is the number one hot spot for tornadoes. And again, the main reason for that is the Gulf of Mexico. That drives that. So looks like we got some thumbs up. Looks like everybody is doing great. Everybody's doing good. Again, thank you, Nessie, for that information. Please keep sharing more information in the chat, please. So appreciate that. So how many tornadoes occur in the U.S. each year? Basically, it's always about roughly estimated at about 1,200 tornadoes are confirmed or hit the U.S. Every year. So roughly about 1,200. So when it comes to that. And again, the tornado record keeping for the U.S. only goes back to 1950. So we do not know the actual average number of tornadoes that occur each year. So only from about 1950 forward is when we can calculate the average. But before that, there was no record keeping, so we don't know and understand exactly what the average was before that. And plus, tornado spotting and reporting methods have changed a lot over the last several decades, which means that we are observing more tornadoes that actually happen. So if you think about it, back in the 40s, 50s, 60s, 70s, really before storm chasing and storm spotting really became a thing, there was clearly a lot more tornadoes that happened that never got reported. Or we're just in an era, we are in an age today that we are blessed to have the amount of data that we have, the amount of being able to have different outlets to provide that information and provide that data to. So we are in a more of a real time data driven age right now. So therefore, we are able to count for more tornadoes than what we ever have because of more people being out there and just more eyes on the weather, and again, more outlets to report that, more spotter networks, more certified weather spotters, and things of that nature. So again, that helps push the numbers up. So yes, so that's about how many happened in the U.S. It's about 1,200, and as you can see, Nessie said that in the UK has around 30. We got 1,200. So again, that is a huge, huge difference. And from what I've read before, in the whole world, there's roughly estimated about 2,000 tornadoes roughly every year throughout the whole entire world. So if you look at that, the U.S. is getting 1,200 of those tornadoes out of the 2,000. So that is a huge, huge makeup. That's why the U.S. is the number one hot spot for tornadoes in the whole world. So again, roughly from what I've read before, roughly there's about 2,000 tornadoes every year in the world, and the U.S. Sees 1,200 of those, and the other 800 are spread throughout other areas of the world. So again, a lot of tornadoes happen here in the United States. So very good stuff. So let's move on to where is Tornado Alley? And again, this is for the U.S. So here in the U.S., Tornado Alley is a nickname invented by the media. So there was no scientist or no meteorologist. None of that made that up. This nickname comes from the media to refer to a broad area of relatively high tornado currents in the central United States. So various Tornado Alley maps look different because tornado occurrences may be measured many ways. So if you look at one map of a Tornado Alley that some media outlet uses, and you look at another Tornado Alley map that a different media outlet uses, they most likely will not look the same. So they will most likely look different when it comes to that. So maps look different because tornado occurrences can be measured, as I mentioned, can be measured in many ways by all tornadoes. Tornado county segments, strong and violent tornadoes only, and databases with different time periods. So again, they can look very different due to how many different ways that they are measured. So, however, the idea of a tornado alley can be misleading. The U.S. tornado threat shifts from the southeast in the cooler months, which it does. So that's like February, March, sometimes into beginning of April. So southeast being Mississippi, Louisiana, Alabama, sometimes Georgia as well when it goes into that. So, and then toward the southern and central plains in May and June. So that's when it shifts back to the west and a little bit of the northwest. So, and the northern plains and Midwest during early summer. So the northern plains are talking about here in the early summer, which it's early summer right now. They're talking about North Dakota, Nebraska, and South Dakota. That's just usually on a normal weather year. That's normally how it goes. So it doesn't happen all the time, but that's just normally how it goes. So tornadoes can occur and have been reported in all 50 states. So yes, even Alaska has had tornadoes reported, and I believe they have had 2 confirmed ever. I believe one in 1950, and I believe another one in 2006. So again, even Alaska has had tornadoes. Hawaii as well. Every single state in the United States has had a recorded tornado. Please remember, violent tornadoes do happen outside Tornado Alley every year. So sometimes people get the misconception that only the violent tornadoes happen within the parameters or within the scope of Tornado Alley. That is not true. Violent tornadoes will happen anywhere and everywhere that they can, to wherever the ingredients come together, wherever the ingredients and conditions are correct and right, and that's where a tornado will happen at. So it does not discriminate. It does not care about which border, state border that it crosses. So again, don't be fooled by a Tornado Alley map. It's just kind of like the hotbed hotspot, but outside of that, tornadoes happen all the time outside of that area that's drawn up of what's known as Tornado Alley. So please let me know if you're still enjoying and having fun here. I know it's early here, Central Time. It's 9:52 a.m. Central Time. It is 10:52 Eastern. It is 8:52 Mountain and 7:52 Pacific Time. So I know some of you might still be sleeping, might still be waking up, and that's perfectly fine. That is awesome. So I'm thankful for one person on Twitch who's watching. Got 5 on YouTube. Looks like got none right now on Facebook, and got 2 on Kick. So hey, I'm thankful for all of you. So even if there was 0 of you in here, I would still be teaching this. So I appreciate that. So again, I really do appreciate that. So Libby says, good morning, John Boy in chat. Good morning to you, Libby, as well. Thank you for being here. Thank you for joining in. Definitely appreciate that. Again, I know it's a little bit different than what I normally do, but I really wanted to come on this morning and, really try out the multi-streaming. And so far, so good. Definitely highly appreciative of everybody being here. And again, so yes, just very thankful for that. So you guys are awesome. Saved by His grace, Libby, everybody who's in here, my wife, Nessie, everybody else who's in here that I can see from YouTube and everywhere else. Thank you so much. So just very thankful for that. So this very, very gracious of all of you. And it looks like we have, from YouTube, looks like we have Monk 58. Thank you for being here this morning. Appreciate that. Appreciate all of that. Appreciate you being here. So thank you so much. Again, I know it's early, but it's never too early, I guess, to learn about our favorite subject as tornadoes. So awesome. So let's keep moving along here. So now we get into the when, right? When are tornadoes most likely? Well, tornado season, technically we have what's called a tornado season here in the United States. So technically, tornado season usually refers to the time of year the U.S. sees the most tornadoes. So that is going to be basically between March and usually March 1st to July 1st. That's typically what is defined typically as the tornado season in the United States. So typically that's what is defined as. So March 1st to July 1st. That's typically tornado season for us because that's the changing of the weather. It is still becoming late winter, turning into spring, and that is so that is what is driving a lot of that change in the air mass, a lot of change in from hot to cold, a lot of change in different layers of the atmosphere, change in the jet stream, changing of the seasons. So a lot of things is happening there. So again, typically what is regarded as tornado season in the United States is March 1st to July 1st. But again, tornadoes can happen at any time inside and outside of that area. So So the peak tornado season for the southern plains, so we're talking Texas, Oklahoma, and Kansas, is from May to early June. So now we're talking peak, like where things are the most intense, where we see the most tornadoes, where we have the most volatile weather at, where we have the most instability, things of that nature. So peak season is technically from May to early June, and then on the so if we go back, so on the Gulf Coast, it is earlier in the spring. In the northern plains and upper Midwest, as we talked about, it becomes later in the tornado season is in June or July. So again, things change there. So because of the jet stream, and so that's what changes that out. So but remember, tornadoes can happen at any time of year. So again, yes, any time of year, tornadoes can also happen any time of day or night. But if you go back and look at all the record keeping, most tornadoes do occur between the times of 4 p.m. and 9 p.m. because that is when you're getting the most energy of the day from the sun. The sun has already baked. The sun has already baked the environment. The sun has pretty much exploded the environment. So that is why between the hours of 4 and 9 p.m., that is why it's the most volatile. And that's usually where we find the most unstable air is in between those times. So again, we can thank the sun for that. That is the reason why. So when it comes to that, but yeah, so that's basically when our tornadoes most likely. So again, they pretty much start off, or pretty much, I shouldn't say start off, but pretty much, on a usual typical year, we'll find mainly the most tornado threat will be down in the southeast. Again, that's going to be Mississippi, Alabama, that region, and that's going to be in the like March, early April, late April as well. And then it likes to shift back to the plains, the central plains, which is Texas and Oklahoma and Kansas, as well as Arkansas, all those other places as well too. And then when we get into the months of like June and July is when it likes to go further north up into Minnesota, South Dakota, North Dakota. So it's usually how it works, but it doesn't always work that way all the time. So now we'll move on to what is the difference between a tornado watch and a tornado warning. I think a lot of you might be familiar with what these are, but there are sometimes people who do not understand the difference between a watch and a warning. So the easiest way to describe what a watch is just saying, hey, the SBC is going, hey, all of the ingredients are there for a tornado to happen. So what we're going to do is say, hey, there's favorable, all of the ingredients look favorable, all the atmosphere looks favorable, everything that goes into Tornadogenesis looks favorable. So we're going to put a watch out and say, hey, these conditions are favorable. So we're just going to pre-warn you. We're going to put out a watch and say, hey, just be on the watch, that just know that the conditions are right for tornadoes to happen. So a watch is pre-warning you. A watch is giving you ample time to either have your your safety weather prepared and awareness and everything like that. So a watch is just really just warning you of that the conditions are favorable for tornadoes to happen. So that's basically the gist of a watch. Now, a tornado warning is completely different. The watch is saying, hey, it's favorable. Obviously, there's no tornadoes spotted yet. There's no tornadoes going on yet. It's just letting you know that the atmosphere is primed for tornadoes. A tornado warning says, hey, now we're getting serious. So now it is really happening. So a tornado, a warning is either radar indicated, it is observed, it is confirmed. So a tornado warning is that a tornado is imminent, that a tornado is either ongoing, it's in process, or it's about to be in process. So that is what a tornado warning is. It's warning you that a tornado is outside or could possibly be outside your house, be outside your window. So again, it is what a warning is. It's warning you of the pure fact that that tornado is out there and that it could be menacing to you. So again, it's warning you. A warning is that it's already in place. It's just about to take place. It's radar indicated. Um, that it's observed, that it has been confirmed. But anytime you have a tornado warning, take it as if it's already on the ground. Because again, because of the radar data holes and just the way that radar gets received back, sometimes the radar isn't always 100% correct. So if it says, even if it's radar indicated, does not mean that it actually is not on the ground. So anytime you hear a tornado warning, please just think of it as the tornado is already on the ground. So again, I won't beat that over the head, but I think that just a little bit of refresher to understand the difference between the watch and the warning. So how is tornado strength rated? So talked about this quite a bit before in some of my streams as well, and some of just understanding and teaching. So how is tornado strength rated? So it's rated here again in the United States, and on what is called the enhanced Fujita scale. And I will take you over here and show you this awesome scale here that the NWS has. So we will take a look at this. The enhanced Fujita scale came in on February 1st, 2007. Before that, it was called just the Fujita scale. They just put the E in front of it and enhanced, because what enhanced means is that they were able to put in more damage indicators and things like that. So they went back and enhanced that scale. So if you look at the scale goes from 0 to 5. What it does not have here, what I mentioned before, is there's actually what's called EFU. Which stands for Enhanced Fujita Unrated, which is pretty much it's undefined, it's undetermined due to several different situations, or due through several different findings and things of that nature. So again, there is also an EFU. Again, I did not make that up. That is an actual real thing. So, but again, so 2007, the EF comes into play. And again, this rating has to be based off of 3-second wind gusts. So the wind gust has to be what you see here for at least 3 seconds. So EF0 is 65 miles per hour to 85 miles per hour. So why is that significant? Because that is significant because if you look at sometimes when we get here in the U.S., we get large MCS convection systems. We get a lot of things like that. So when they get into a bull echo or to a derecho, if they happen to become a derecho or whatever else, a lot of times the winds inside of those types of MCS convection systems will be 75 mile an hour plus, 80 miles an hour, things of that. So you're sometimes even more, sometimes 90 or plus, sometimes 90 miles an hour or more. So when we look at that and you look at that, you go, oh, basically you are facing basically an EF0 rating when you see winds like that. And sometimes when the winds get up, as you can see, when the winds get up to 86 miles an hour or more, which happen a lot in straight line wind thunderstorms. Sometimes they're 90 miles per hour plus, things like that. You're talking that storm, even without a tornado on the ground, would technically be an EF1 if that tornado, if there was a tornado on the ground. So that's why, just for comparison, it's very good to understand exactly what those plus 80 mile an hour winds, 85, 88, 90 mile an hour winds compared to tornado ratings. So just briefly, just go over it real quick. EF0 is 65 to 85. EF1 is 86 to 110. Then we got EF2 from 111 to 135. EF3 from 136 to 165. EF4 from 166 to 200. So, and then EF5 is anything over 200 miles an hour. So that is 201, 202, 203. But if a tornado were to get rated at exactly 200 mile an hour winds, it would actually be considered an EF4. It has to be over 200 miles an hour. So that is the scale that we use here in the United States. It's the EF scale that we use to determine and rate tornadoes. But again, this is a great visual to give you more of an understanding of what that looks like and how you can, if you ever are underneath a strong thunderstorm and they go, well, that thunderstorm that just passed by had wind gust of 90 miles an hour or had wind gust of whatever, you can go back and look at this scale and go, that was basically an EF1 type of tornado wind that came through here. So again, so good stuff with that. And just for just to let you know, so in the U.S. currently here, the strongest tornado that we have had confirmed this year so far has been an EF4. It is an EF4, and only one. We've only had one EF4 confirmed here in the United States. So the highest so far in the United States is one EF4, and that was in Enid, Oklahoma. Saved by His Grace says, dear ones, it's my bedtime. Have a peaceful evening day. God bless you all. Thank you, Saved by His Grace, for being here. Thank you so much for joining in. Hopefully, maybe see you sometime later today if Brother John McKinney live streams. But thank you so much for being here. God bless you. Thank you so much always for your encouragement and your support. Saved by His Grace. Thank you so much. So yeah. So again, but again, just to get back on topic there, to get back on that. So we in the United States have only had one EF4 confirmed. So everything else has been EF3s and less this year in the United States. So clearly no EF5s and only one EF4. So which is really good because we don't want to see EF4s and EF5s because those things will wreak havoc and those things will destroy everything basically in their path. So let's move on just a little bit further on how you get more into a little bit of what the EF gets into. So the EF, and you can see all of these, the EF uses, again, they use 28 DIs, which are 28 damaging indicators. And inside of those, they have what are called the 8 degrees of damage, or DOD. So that's what they use as inside of the damage indicators. So when the National Weather Service goes out and surveys tornado damage, this is the exact tool that they are using. They're using what you're about to see here. They're using these damage indicators. They have 28. You can see 28 of those on your screen. So they are utilizing these 28 damage indicators that come. So again, when a National Weather Service surveyor goes out and looks at the damage, they have this tool with them. They are checking off check boxes and looking at trees. They're looking at everything you see here. They are looking at these types of damage indicators, and then inside of these are looking at the 8 degrees of damage that goes with them. So this is what they are utilizing when they go out there. And so I know a lot of people like to go, well, how come this tornado wasn't an EF5, and how come I can think of Rolling Fork off the top of my head. I can think of the Kentucky one back in 2021. I can't think of the name off the top of my head here. there's there's a bunch of them. The Tuscaloosa one. A lot of them. A lot of people will say, well, how come they wasn't rated an EF5, and it should have been rated an EF5. But again, the NWS is utilizing the tools that they have to go out, and they have to follow the strict protocol, and utilize this. So this is the reason why, um, and what's used. This is the reason why it gets rated what it gets rated. So again, this is what NWS uses. So, and this is it's not like they go out there and just go, hey, this should be an EF5, this should be this should be that. Again, it's just based off a rating. It's based on what they have to use. So to go off of that. So, and a lot of times they will go back though and recalculate things that happen. And the thing is, uh, that happened in Enderlin. Last year, June 20th, 2025, the Enderlin EF5, which was originally, I believe, rated an EF3. Um, so what they will go back is they will actually go back and calculate or recalculate things as well, and say, and so thankfully when they went back and recalculated the how far that the train car got thrown, which was over 475 feet. So they went back and calculated and said, okay, well, in order for this train car to fly 475 feet, it's empty train car. How much does it weigh? How far did it fly away from the tracks? So you can figure out the time, the distance, and the speed. And then they said, okay, well, how much force is needed? So when you have the time, the distance, the speed, you can figure out the force that was needed. And they said, okay, this had to be over 200 miles per hour wind to do that. So that's why the Enderlin got upgraded to an EF5, all because of a stopped freight train in its path. So had the freight train never been there, an EF5 never would have got recorded that day. So that is why. So again, sometimes they will go back and calculate things, or try to recalculate things and look at things, because that's part of their job as well. But when they are out in the field, this is the 28 DIs that they are using. So, and then this just gets into the original F scale. So this is what the original F scale looked like before. And as you can see, the winds are way different. So for the enhanced, they went back in and they, again, they recalculated and recalibrated the wind speed. Um, and so yeah, so they are, again, so if you look at the difference between the EF today and the F scale that was used up until 2007, you can see that the major difference in a lot of things is the wind calculation. So as you see, the F5 was originally calculated at 260 to 318 miles per hour. So very different. Nowadays, it's only calculated at over 200 miles per hour. So huge difference there. Looks like Libby says, do they go back to recalculate, or do they give a preliminary and continue their calculations? I think that might be an answer. That might be possibly both, but a lot that I know of, and the research that I know of, is that they do give that um, preliminary, and so I don't know if they are still continuing their calculations. I think a lot of times they go back and they look at, they'll do like a rundown. As far as I know, like from what I know, they'll do a rundown of all recent tornadoes, especially stronger ones, and go back to see if there's any type of indication that might make them stronger than what they, or to give them a different rating than what they have. So as far as I know, they give the preliminary and then they go back and recalculate. But what you say is they could continue their calculations, and it could be ongoing at all times but I can only speak of from what I really know about there, Libby. So, but great question. But if you have any insight to that, please let me know in the chat. Please fill us in there, because that is would be good to know. But again, all I know is that they give the preliminary and then they go back and do it. So, but if you find information, um, Yeah, please let me know because a lot of times, sometimes the recalculation will come from a third party, um, um, like a third party, you know, not even from not even from the National Weather Service. It'll come from a whole different third party that they'll work in conjunction with the National Weather Service, and that's actually what happened with Enderlin. It actually was a third party that was able to figure that out and work with in partnership with the National Weather Service on that. So again, that just kind of leads me and what I've seen that they give out the rating and then they go back and calculate as needed on that. So um, with that, so good on that. Thank you very much, Libby. Thank you so much. Great question. You all have great questions. Um, but yeah, but so before I move back into the basics 101, this is as a great overview of the EF scale, why it's implemented for, how it's implemented, how it's still utilized today. And again, it is based off of damage. It is not based off of pure wind speed. So it is from the damage that is calculated that then we calculate the wind speeds that was utilized or that the wind speeds had to be in order to cause that damage. So, but from that, so thank you very much, Libby. Again, great question there. So the $1,000,000 question, right? Libby says that makes sense that there are tiers of investigators that review the damage. Yeah, that would definitely make sense when it comes to that because I think a lot of times they definitely don't want to overshoot a rating and go, oh, this was an EF5 or this was an EF4. And then, so a lot of times they like to play it safe. But again, they're also utilizing the data that is in front of them and the damaging indicators that are there. So I know there's a lot of people who are saying because we were in a 13-year drought. I'm sorry, 12-year drought. We were in a 12-year drought from 2013 through 2025 without having an EF5. And sometimes people would come up with these conspiracy theories and say, well, they don't want to, panic the public. They don't want to, that's why they're withholding EF5, rating. And so there was a lot of conspiracy theories involved with that as to why it took 12 years for us to get another EF5 rating. But nonetheless, last year broke that 12-year streak that we had going on. And actually, it would be awesome to see 0 EF5s every year because that means that there's not a loss of life, there's not a loss of property, not a loss of livestock. So it's a really good thing when we don't see EF5s get rated out there. So because the pure damage and carnage that you see from EF5s is something that is pretty much unbelievable. Pretty much, if you've ever seen an EF5 documentary like Joplin, or if you've ever seen any type of when an EF5 goes through a city, it is pure damage. So carnage. So good on that. Thank you so much, Libby. So again, the $1,000,000 question is, how do tornadoes form? And if you've ever heard me talk about it in previous streams and previous weather sessions, is the truth is we don't know. We don't fully know how do tornadoes form. It's not fully known. Now we do have some good data and some good scientific empirical data to back that up and things like that. But again, to fully understand how tornadoes form is just not understood. We don't know it. So we do, but some things we do know, which we do know, like usually the most destructive tornadoes occur from supercells, which again, a supercell is a rotating thunderstorm with a well-defined radar circulation called a mesocyclone. So a lot of times storm chasers and meteorologists will shorten that and just say, hey, I'm under the meso. I can see the meso from here. So a lot of times they'll just take off the cyclone and say meso. So if you hear meso, that's usually what they're talking about in the stream. when you hear them. So supercells can produce damaging hail, severe non-tornadic winds, frequent lightning, and flash floods. Yes, that is very true. Tornado formation is believed to be dictated mainly by things which happen on the storm scale, which we will dive into here briefly and get into a little bit more of the tornadogenesis side of things. So, in and around the mesocyclone, recent theories and results from the Vortex 2 program suggest that once a mesocyclone is underway, tornado development is related to the temperature difference across the edge of the downdraft wrapping around the mesocyclone. Mathematical modeling studies of tornado formation also indicate that it can happen without such temperature patterns. And in fact, very little temperature variation was observed near some of the most destructive tornadoes in history. We still have lots of work to do. So again, what is that saying to breaking it down? It's saying, again, we don't understand fully why they form. We don't understand where they're going to form, why they form, things of that nature. But we do have some data to help us kind of get into that. And once I get into tornadogenesis, there is an acronym to use for tornadogenesis that really there's really four things that are needed in the environment to really get a tornado pumping and tornado going. We will get into that here briefly. So what do storm spotters look for when trying to identify a tornado or a dangerous storm? Here are terms that you might have heard or have previously heard on storm chasing channels, storm chasing, watching streams, watching meteorologists, things of that nature. So inflow bands. Inflow bands, you might have heard this term. Inflow bands are ragged bands of low cumulus clouds extending from the main storm tower, usually to the southeast or south. So again, inflow bands means it's exactly what it means. It's coming in. It's inflow coming in, that the storm is taking a breath and it's drawing in. So it's the inflow that's coming into the storm. The presence of inflow bands suggests that the storm is gathering low-level air from several miles away, and that's what it's doing. It's pulling in air from several miles away. And what is pretty cool about what you would know if you had a flag, and let's say there was a big supercell storm that was ingesting or had a bunch of inflow, you could look at that flag, and that flag would be pointed straight at that storm. So that flag is a good indication of, if you're ever outside and you see a flag and you can see the direction that the storm is in, if the flag is pointing directly at that storm, you can pretty much say and tell this storm is still full of inflow. It's still producing a lot of inflow, which means that it can still be strong. The inverse is when it has a lot of outflow. That's usually when it's getting towards the end of its life cycle. So, or being less severe, but it becomes more outflow dominant. So again, inflow is more of creating more of a severe severe environment. Outflow is creating a more of a less severe environment. So again, just a great visual. Again, if you have a storm out there and you can see flags or something that's easily can be pointed in the wind and they're pointed towards that storm is inflow dominant. So if they're pointed away, it means that it's basically outflow at that time. So just a great indicator for that out there. So, and another thing is, so if the inflow bands have a spiraling nature to them, it suggests the presence of rotation. So if you ever see inflow bands and you see them rotating, it does suggest the presence of rotation. So good to know that. Looks like we have Debbie in here this morning. Thank you very much, Debbie. Appreciate you being here this morning. Thank you so much. You are awesome. Hopefully everything is going well with your brother. Hopefully have been praying for him. So hopefully he's doing a lot better. So thank you very much, Debbie, for being here and for modding. Thank you very much. Definitely appreciate that. The beaver's tail is a smooth, flat cloud band extending from the eastern edge of the rain-free base to the east or northeast. So now we're talking about different side of the storm. Um, but so this one's called the beaver's tail. It usually skirts around the southern edge of the precipitation area. It also suggests the presence of rotation. So again, inflow bands, beaver tail. Here's a big term that I think a lot of us have heard and a lot of us have know about, and that is wall cloud. And a lot of times, if you see a wall cloud, a lot of people situate or they automatically that becomes synonymous with a tornado, but it's not does not always mean that a tornado is present. So a wall cloud is an isolated cloud lowering attached to the rain-free base of a thunderstorm. So remember, the wall cloud is going to be in the rain-free base of the thunderstorm. The wall cloud is usually to the rear of the visible precipitation area. So where you see precipitation, to the rear of that is where you are going to see the wall cloud. The wall cloud will line up in the rain-free base of the thunderstorm. Thank you so much for subscribing here. Thank you so much. Definitely appreciate that. Thank you. And it looks like I am now at 2,100 subs on YouTube. So very, very thankful for that. Thank you, Ida, for subscribing. Thankful to hit 2,100 subscribers, I'm sorry, on YouTube. So, but to move into a little bit more of the wall cloud, a wall cloud that may produce a tornado can exist for 10 to 20 minutes before a tornado appears. Let's read that again. And thank you so much, Mike, for subscribing. Thank you so much for that. Appreciate that. Thank you for your support, and thank you for being here this morning. So again, a wall cloud that may produce a tornado can exist for 10 to 20 minutes before a tornado appears, but not always. A wall cloud may also persistently rotate, often visibly. So have strong surface winds flowing into it and may have rapid vertical motion indicated by small cloud elements typically or quickly rising into the rain-free base. So again, that is a basically I won't dive into too much further into the wall cloud, but that is how you can separate the wall cloud from a different cloud. The wall cloud is going to be part of the rain-free base, and it's going to be to the rear of the precipitation. So, but yes, so that is basically a wall cloud there. The RFD, I'm not going to beat this over the head, but just in case you don't understand what the RFD is, this is what you will hear a lot and almost all the time on streams, on almost everybody's storm chasing stream. The RFD is a downward rush of air on the backside, so the west side of the storm, 99.9% of the time, unless the storm is coming off going from east to west, which happens very, very, very rarely. So, but I won't bust into that or dive into that. 99.9% of the time, they're going to be coming from west to east. So on the west side of the storm, the back side of the storm, that descends along the tornado. The RFD looks like a clear slot, and that's what we see when it wraps around, or a bright slot just to the rear, southwest of the wall cloud. It can also look like curtains of rain wrapping around the cloud-based circulation. So we've all heard of RFD. So the RFD causes gusty surface winds that occasionally have embedded downbursts. The RFD is the motion of the storm that causes the hook echo feature on radar. So again, why do we see that hook echo on radar? It's because of the RFD when it comes to that. So, but I won't beat that because over the head, because that is something that you probably most likely hear a ton about, a ton of. So, but the next one is a condensation funnel is made up of water droplets and extends downward from the base of the thunderstorm. So a condensation funnel, what you're going to see, that is going to be a funnel cloud. So if you hear a condensation funnel or funnel cloud, that's the same thing. It's just a different terminology for it. Uh, if it is in contact with the ground, it is a tornado. So again, remember, if it comes in contact with the ground, that's when it becomes a defined tornado. It can be in contact with the ground for 1 second, for a split second, and it can still be defined as a tornado. That's all it takes. Otherwise, it is a funnel cloud. If it never touches the ground, if you see it 10 feet off the ground and you go, whoa, this looks like a tornado. If it's not touching that funnel cloud, it's still just labeled a funnel cloud. Dust and debris beneath the condensation funnel confirm a tornado's presence because, again, we can't see wind, so we need other visuals to show us. That is the condensation funnel. Again, that would be dust and debris and rain droplets that give us that confirmation of a tornado. So, and it says, be careful. Tornadoes can form and be in contact with the ground without a fully condensed funnel. So, yes, that is absolutely true. And I've talked about this before. You can look at the base and see it spinning, and you can see debris on the ground. You can see, dust and everything else being picked up and swirled around. But when you look up to the thunderstorm, and you go, it's not even in full contact with the ground. Technically, it is in full contact. I'm sorry, technically, it is in full contact. It's just not fully condensed. So, again, it looks kind of weird when you see that. You look up and you see it fully condensed, like 1,000 feet higher than what it is on the ground, but it's still circling and swirling. It looks rather strange, but it is still a tornado. So, with all that being said, I have to. Libby says, do those tornadoes that are only on the ground for a few seconds or a minute usually receive an EFU rating? Most likely, yes. And I will dive back into that, Libby. I will answer that question fully for you. I have to take roughly about a 15-minute break here. But I will be right back. I will be right back as quickly as possible. But again, be about 15 minutes or so. But yes, very thankful for all you here. Very thankful for everybody who's joining in on Twitch, on Kick, Facebook, YouTube. So again, making the foray into multi-streaming. But again, I will answer that for you fully for you, Libby. Here, give me about 15 minutes, and I will be right back. God bless you all, and I will see you guys here shortly. Thank you very, very much. And again, give me about 15 minutes. So, thank you guys. All right, everybody, I am back. Thank you for still being here. Thank you for uh, waiting around. Appreciate that. Thank you so much. Um, Let me know if thumbs up, you can hear me okay, see me okay. Make sure that we still have a great connection here going on. So, looks like to get back into Libby's question here. Um, do those tornadoes that are only on the ground for a few seconds or a minute usually receive an EFU rating? Um, I would say yes to a certain point because definitely if they're only on the ground for a few seconds, I would definitely say that because, clearly if it's on the ground only on the ground for a few seconds, it's most likely not going to have enough time to do any type of damage or any type of you know things of that nature. So I would say yes to that question. Um, Definitely. But there are, certain times as soon as that gets on the ground, it might unfortunately go right on top of a structure or things of that. So it only takes a few seconds to damage that structure. So, again, there's certain things that go into that. But yes, I would agree with I would say yes to your question there, Libby. So when it comes to that, so definitely, um, but the EFUs can get rated for a number of different reasons. It's just things that like they couldn't make it out and survey it. Sometimes, so like let's say if a tornado comes out and damages like a federal prison or different types of just places that where the NWS that cannot get into. And there are times where tornadoes do happen to damage, prisons or other certain places, and the NWS just cannot get there too because they're not allowed into certain facilities in certain areas. So there are certain things sometimes that to where the NWS just goes, well, we can't go survey the damage. We had to just mark it down as an EFU, um, and that's what happens. So sometimes they just cannot go see the damage themselves. So, or if the damage is in some sort of uh, area like anything that would put them at harm or put them at peril, they won't go and look at the damage. So that's why a lot of times EFUs happen, even though you could look at the damage and probably survey it visually and go, oh, that's probably EF2, EF3 damage. So, but again, that's a lot of times why EFUs happen or how they get rated. So, you're welcome. You're welcome for that, Libby. So again, the NWS can only whatever they can survey is only what they rate. So and again, they have limited sources. There's only an X amount of surveyors who go out and survey. Now, can surveyors come from different weather forecasting offices? Absolutely, they can. Like in times of like huge tornado outbreaks and things of that nature. But again, at each weather forecasting office, they are regulated to just a certain amount of surveyors who go out and survey. Um, so again, yes, that's why a lot of EFUs happen. And so again, great question, Libby. You are awesome for all your questions. So thank you so much for that. And again, thank you so much for y'all being here at about 10:58 a.m. on this beautiful morning, July 8th. So very thankful for all of you. I know it's a little bit different, like I mentioned before, but different is good. So very awesome, very blessed for all of you. So before I move on to the next topic, which are tornado types, which we will get into, I want to give you some great information on Tornadogenesis. So, really, and this is going to be an acronym that you guys hope will take back and utilize and use. And again, this is going to be talking about the four, really the four makeup, atmospheric makeups that are really needed for tornadogenesis. So, let's jump into some tornadogenesis. So, very great stuff here if my mouse will like to work um, when it comes to that. Um, so let's take a look at a little bit of the science formation behind tornadoes that we talked about. Even though we can't predict them, we don't really know how they form, but we can utilize these four different types of atmospheric conditions and say if we have these four atmospheric conditions, this is pretty much when tornadoes are primed and tornadogenesis can start to take place. So, tornadogenesis is a keyword that you will hear a lot on storm chasing streams, and a lot of meteorologists like to use that as well. So, again, what's kind of the blueprint for tornadogenesis? So, which is tornadogenesis is the birth of a tornado. So, really, there is this acronym, and this acronym is called SLIM. So, if you want to write this down, if you want to screenshot this, if you want to whatever else, I will also provide a link. I can also provide a link to in the description as well, so you can come back and look at this whenever you want to. So, the acronym is SLIM. SLIM. So what do we need for S? We need shear, wind shear. Again, wind shear. That is the changing of wind speed in different direction with height as you continue to go up in the atmosphere. So wind shear, that is one huge element that we need. So we need changing of the winds at different heights. That's going to give that shear. That's going to give it that motion, that rotating type of motion. So shear is one major part that plays into tornadogenesis. The next one is lift. We need lift, right? We need air to be lifting. So once the air starts lifting and we have the wind shear, well, now we can start to have a vertical rotation instead of horizontal rotation. So we need lift, or what is also known as a vertical lift. That's what we need. So how do we get lift? Lift is a forcing of air upward in the atmosphere, often by a cold front or other boundaries. So there's different things that come into how we get lift in the atmosphere. So again, we need shear. So we need wind shear, which is a changing of wind speed in direction with height. It says over a community or over, in different parts of the atmosphere. So we have shear, we have lift. So now we got two ingredients. Now we need two more really ingredients to go in together. We need instability. So that's the tendency for air to rise by itself through heating. Warmer air is more unstable and will rise faster. So instability, what do we need? We need energy. It's unstable. It's instability. That's where the CAPE values come into play. The convective available potential energy. That's where that comes into play at. So the joules per kilogram, the joules per kilogram is how that's measured for CAPE. So CAPE is the rocket fuel out there that's measured for the storm. So that's where instability comes in. So we need shear, we need lift. Now we need the environment to be really chaotic and very unstable. And we really need that warm air to really be rising and rising quickly. That's really an ingredient. So now, just to really help aid and to knock it all off here is moisture. So we need moisture. So we have shear, we have lift, and we have instability. Well, now we need moisture to help aid in that. So moisture, what is moisture? Moisture is air laden with more water Air laden with more water would be more buoyant. So we need buoyancy. It's another key term you might hear out there, buoyancy, and will tend to rise. So what do we look at a lot with moisture? Dew points and humidity. So when you look at, usually when you have higher dew points, you usually have higher humidity, which means there's a lot more water vapor in the atmosphere. So again, that's why higher dew points usually can help aid and tend to creating and helping in the tornadogenesis of tornadoes. So again, the acronym is SLIM: shear, lift, instability, and moisture. So again, and different meteorologists and scientists and storm chasers will say they'll look at these four, and then they'll look at it and say, well, I think shear is more important than lift, or I think lift is more important than shear, or I think instability is the most important. Really, there is no define what is more important than the other when it comes to tornadogenesis. But definitely, what is most commonly talked about though is wind shear, because you need the shear, or I guess which is most commonly that a lot of storm chasers, a lot of meteorologists will say it's just like they'll say, "Oh, to me, what's the number one thing I think is the most important?" A lot of them will say shear, just due to the fact that you do need wind changing at different directions to create that rotation. So a lot of times you'll hear shear as being the number one, but technically one does not really outshine the other. So again, shear, lift, instability, and moisture. And if you're still following along with me, if you're still enjoying what you are learning, please write SLIM in the comment section. So if I could see SLIM in the comments, that would be awesome. That would be great. Just to let me know that you guys are still following along and enjoying what you are learning on this beautiful morning. So definitely thankful for that. Again, please, if you would please write SLIM in the comment section. So that's going to be awesome. We got Libby writing SLIM. Thank you, Libby, so much for that. We got Debbie with SLIM. We got Monk with SLIM. Thank you so much. You guys are all awesome. But again, it's a great acronym to utilize and to be able to understand the four main ingredients, really the four ingredients that are there that you really need in order for that tornadogenesis to take place. But again, you can have all of these four ingredients and they can be super high ingredients and they can be off the charts, but that still does not mean that a tornado is going to drop. So you can still have all these in place, but it still does not mean that's going to happen. So it just the thunderstorm is going to drop that tornado when and however it pleases. And again, just because they're all there does not mean that it's going to happen. It just means that it has the best chance of happening. So here we go. So once wind shear, lift, moisture, and instability are in place, we can start whipping up thunderstorms. So again, that's the prelude to thunderstorms, as well as helping convection with thunderstorms as well. All tornadoes start with a thunderstorm, whether it's a supercell or a non-supercell, but they still come from thunderstorms. When potential heat and humidity are in force, thunderstorms can bubble up like popcorn, and that's like what we see bubbling up. So when it comes to that, so cold fronts, dry lines, and other moving boundaries can help push clouds up and up into the atmosphere until they reach tens of thousands of feet high, often taller than planes fly. So if you've ever been in a plane and you looked out your window and go, oh, whoa, I'm 30-some thousand feet up, and this cloud I'm seeing off in the distance is, double my height, or that is because that is a huge thunderstorm reaching up, 50, 60,000 feet into the air. So a lot of times If you see that from your window from an airplane, it's actually pretty cool to see, at least in my opinion. So, so why does a taller thunderstorm matter? Because usually taller thunderstorms can interact with more ingredients, such as wind shear and instability aloft. This is where the fun begins. So this is again. So usually that's why a lot of times when people are like, "Oh, this thunderstorm has grown to 55,000 feet, 50,000 feet, 60,000 feet." A lot of times we're talking about because again, the taller the thunderstorm, it gives it more of room to interact with more ingredients. So again, that's why taller thunderstorms are often looked at more intensely than shorter thunderstorms. So we get into thunderstorms twist as they grow. So when vertical wind shear is intense near the surface, it creates a rotating tube of air that is parallel to the ground. So, and I'll come back to that. Looks like we got Brother Jonathan in here. Thank you so much, brother, for being here. Thank you so much for all of your support, all of your just your encouragement. Thank you, Brother Jonathan, for being here. Highly, highly appreciative. Thank you so much. So, good to see you, brother. So again, thunderstorms twist. So remember this: as thunderstorms grow, they twist, and it gives us a visual here on the screen here with this picture of what it's showing, the twisting that's going on. When vertical wind shear is intense near the surface, it creates a rolling tube of air that is parallel to the ground. This is an analogous to the cresting of a wave, and as it gets into shallower water near a beach. This rolling tube of air is the origin of what could become a tornado. So, again, thunderstorms twist as they grow. Heating near the ground helps the horizontal tube of rolling air into the vertical. So it's heating near the ground. That is what helps the horizontal tube of rolling air into the vertical, which could then become a tornado. So again, it's taking the horizontal air and making it vertical, and that's what's happening. The heating, the rising air in the near the ground is helping create that lift, and that's what the lift is. That's how it takes it in the wind shear and helps to create it and make it vertical. So as a thunderstorm runs into additional instability, this rotating cloud can stretch upward and downward and strengthen. So again, instability, the more unstable environment it interacts with, the more it can strengthen. And then it gets in talking about the rotating tubes act as a suction vacuum, bringing up air, and the air falls as rain and air is surrounding and ahead of the strongest part of the storm. This is like the lungs of a thunderstorm that will keep breathing until the storm cannot breathe any longer. Very, very, very great information there. So it is at this stage that a thunderstorm becomes a supercell. So again, supercell is a rotating thunderstorm with a mesocyclone. This suction vacuum also increasingly spins as heat and shear put the vortex skyward, pulls the vortex skyward. When this spin becomes strong, a tornado can form. So again, there we're looking at. So, and we get into a little bit more about the tornadogenesis. So it looks like as the rotation stretches, a downward extension becomes a funnel cloud. So as the rotation stretches upward, a downward extension becomes a funnel cloud. As the spinning vortex strengthens, it could reach the ground. When touchdown occurs, the funnel becomes a tornado and can kick up debris, as we talked about earlier. Now it is a tornado. And tornadoes can have winds from 70 to over 200 miles per hour, and the parent supercells can bring over 60 mile per hour winds and large hail as well. So not only is the forward flank bringing all that kind of wind, the tornado that is tucked inside of the backside of it is bringing even more wind. So, yes, a lot of places get what is called a double whammy. So, what is a double whammy? A double whammy is if you look on a radar and you look at it go over a city, the forward flank. So, let's say a forward flank of that storm hit, I'll just say City X, right? City X. The forward flank went over City X, and the winds were 60 plus mile an hour. Dropped a bunch of hail on it. Well, coming up the rear, behind inside of that storm, but behind on the backside of that storm is a tornado. So not only did you get hit with the forward flank, you got hit with the rear flank as well. So you just got double whammied. So that is not something that a city ever wants to be a part of. So again, the forward flank can strike or will strike first, and then the rear flank where the tornado is at can strike second. So if it's all moving in the general vicinity of the same direction, that's where towns can get double whammied at. So when it comes to that. So again, that is basically the what is really needed for tornadogenesis. It's slim. It's shear, lift, instability, and moisture. That is what the key ingredients are needed for tornadogenesis. So really great to point that out when it comes to that. So questions, comments, concerns, still having fun, still having a great time, please let me know. Again, very thankful for all of you. Very blessed. Very thankful you all are here right now. So any questions, please let me know regarding tornadogenesis or anything. Maybe something I didn't cover, maybe something that you know about and maybe I didn't talk about it. Please let me know, because I can only teach you what I know, but I would love to learn from all of you as well. So very thankful again for people who are watching on Twitch, people who are watching on YouTube, people who are watching on Facebook, and the people who are watching on Kick. So very happy to be multi-streaming today. Very happy to be growing my platform, thankfully, with all of you and grateful for all of you. So very, very thankful. So again, please let me know if you have any questions in the comments. Please let me know if there's something that maybe I did not cover when it comes to tornadogenesis. So yes, so please let me know when it comes to that. So, but besides that, let's jump back in to Tornado 101. So we will now move on to types of tornadoes. Types of tornadoes. And that's going to be, as I mentioned, and I'll go over this briefly. Tornadoes come from two different types of thunderstorms. The main one that they come from are supercells. Supercells are the main ones that spawn tornadoes. Those are the main ones. Again, what is a supercell? It is a rotating thunderstorm that has a meso. So again, it has to be rotating in order to be called a supercell. So the majority again will come from supercell tornadoes. Now, what are the other ones come from? Well, those are the ones I talked about a little bit earlier. You can get gustnados. They'll come from MCS systems, or also called QLCS, so quasi-linear convective systems. Remember all QLCSs are MCSs, so that's why sometimes people will just say MCS as well. So about 20% of tornadoes come with basically MCS type of convection system. So all the other 8 out of 10 tornadoes come from supercells. So very, very rarely, very rarely do they um, come from uh, QLCSs slash MCSs, deratios, things of that nature. So, and again, they're usually not very strong. They're not very, as we know, they're not usually highly rated on the EF scale when it comes to that. So, usually, they'll come from that. And then there's also the land spout, which we talked about before. The land spout is is a tornado, but just from a non supercell thunderstorm. So, and water spouts as well. Water spouts are also tornadoes on water, but formed from non supercell tornadoes when it comes to that. So, again, they can be kind of confusing. But again, the most of the tornadoes are going to come from supercell thunderstorms. That's what mainly meteorologists are looking at. That's mainly what storm chasers are looking at. That's mainly what they want to see fire are supercell thunderstorms, and then see them fire without any other storms around them. So what we like to call, or what is called, discrete supercells. Discrete means being alone, being by itself, not having any type of storms around it that impede the air or suck all the other ingredients out of the atmosphere. So it's not competing with any other storms. So if you can get some discrete as well, which discrete also means two, discrete just means that it's not in a line. Discrete means that it's they're not in a long line or anything like that. So that's really what discrete is. But so really what they want to see is discrete supercells that are unimpeded. So again, discrete supercells are not part of any line. They're not part of any BOECHO or any type of QLCS, things of that nature. But so again, a discrete supercell, that's what a lot of storm chasers like to see, and that's what a lot of storm chasers chase, and they like them to not be have any other competition around it, because then if it can get out there, if a discrete supercell can get out there and it doesn't have to fight for any other environment around any other supercells, it has a better chance of taking off and becoming tornadic because it's not fighting for all the other air around it. So that's mainly why discrete supercells become so destructive. And if they can get off and get away from every other storm, that's a lot of times what can happen. And a lot of times you'll hear the word tail end Charlie. What is tail end Charlie? Tail end Charlie is basically when you look at supercells that have not fired off and come into a full line yet, and tail end Charlie will be before that line starts, will be at the south end, the very tail end of where all the storms have fired up at. And a lot of times people like to chase tail end Charlie because tail end Charlie doesn't have is not fighting for the same amount of atmosphere and same amount of inflow and the same amount of everything else that all the other storms are fighting for. Sometimes tail end Charlie has all of the most ingredients available to it, with the best parameters in place. So a lot of times if you hear tail end Charlie, that is what storm chasers are doing. They're going after the furthest storm to the south, and they are chasing that because they do believe that has the best makeup for tornadogenesis. So again, that is why when it comes to that. So again, please let me know if you're doing great. Thumbs up, please, of let me know that you're doing great here. You're having some fun. You're learning and enjoying what is going on so far. So before we move on, yes, please let me know that you're doing great. So see some thumbs up there in the chat, please. Let me see some that everybody is doing great. Everybody is doing good. So please let me know on that. So please, before we move on to the next part of tornadoes. Debbie gave a thumbs up. Thank you so much, Debbie, for that. Appreciate that. Thank you. See if we can get a few more thumbs up in here before we move on to the next part. We got Monk in here with a thumbs up. Thank you, Monk. Thank you so much for your encouragement and your support. Thank you so much for that. Appreciate that. Highly appreciative of that. So it looks like we still got one person on Twitch, 9 on YouTube, 11 on YouTube now. Looks like we got 0 on Facebook, but that's okay. Making the far way into Facebook, and 2 on Kick. So we're still doing great. Still doing an excellent job. Thank you, Debbie. Thank you, Monk. Thank you for everybody who is tuned in and who has just tuned in. So thank you. We will move on now to detection. How do we pretty much detect tornadoes? So, as you can guess and figure out, we detect tornadoes through, if it scrolls down here, yeah, there you go, yes. So how do we detect? So forecasters and storm spotters have learned to recognize certain thunderstorm features and structures that make tornado formation more likely. Some of these are visual cues like the RFD, and others are particular patterns in radar images like the TVS, which stands for Tornadic Vortex Signature, or also called the Tornado Vortex Signature. So when it comes to that, so very good. So again, TVS. And if you were here for my radar teaching last week, I talked quite in depth about how to read a TVS on velocity. So storm spotters have been trained to recognize tornado conditions and report what they see to the NWS. Storm spotters can be emergency managers or even local people with a keen interest in severe weather who have taken formal storm spotter training in their community. Show of hands here for the people who are in here. How many of you are certified storm spotters, or how many of you were before? So how many of you have some storm spotter training? And what does that look like, currently? So I'd like to know how many of you are currently storm spotters and how many of you maybe previously were storm spotters. So, so please let me know when it comes to that. So, Jonathan says, I had to miss Papa John's stream last night. I wasn't feeling the best. Sorry about that, Jonathan. I'm glad that you are in here and hopefully you are feeling better tonight, brother. So thank you so much for that. So, but again, please let me know if any of you are part of any storm spotter network, or if you're currently a storm spotter, or if you were a storm spotter before at all. So please let me know in the comments there. So great stuff. But again, yes, please let me know if you are or were. Computer programs called algorithms, right? Or algorithms, however you want to say the word, analyze Doppler radar. So again, we can think algorithms for Doppler radar for analyzing Doppler radar data and display it in ways that make it easier for forecasters to identify dangerous weather. So that is so we have a lot of algorithms that are that are analyzing Doppler radar at all times. A storm with a tornado observed by radar has certain distinguished features, and forecasters are trained to recognize them. So when a Doppler radar detects a large rotating updraft that occurs inside a supercell, it is called a mesocyclone, as we talked about. So, or a lot of times the storm chasers and meteorologists and forecasters, whomever else, just like to use the word meso. They will shorten that down to meso. So the mesocyclone, or the meso, is usually 2 to 6 miles in diameter. So the meso is about 2 to 6 miles wide and is much larger than the tornado that may develop within it. So again, it is much larger than a tornado that may develop within it. And thank you, Maria, for subscribing. Thank you so much. I appreciate that. Thank you so much for being here, Maria. Everybody's please say thank you, and definitely thank you to Maria for that. But as well, but I do want to jump into chat here real quick. I fell asleep and I picked up Papa John's Brother John's stream at the end, towards the end, and he was it was quite entertaining, to say the least. So hopefully everything worked out right. I ended up falling back asleep before I finished his stream, but what I saw there towards the end, when he was on going to help out other I think it was other storm chasers or something. Somebody helped me in the comments here. But please, but from what I've seen, I believe he got contacted by somebody from the Storm Spotter Network, and then he went to help somebody out. But yes, it was very, very it was very, very what do you want to call it? I don't know if intense is the right word, but dramatic maybe is the right word. Things of that. So, but yeah, so very, very cool. So, Libby says Otis, and Nessie says Otis. Okay, so that is awesome, because if we're talking about the Otis that I know, they are the ones that fly their drones into tornadoes. So that is very awesome if that's who he went and helped and pick up last night. So that's very awesome. But very cool. Otis does a lot of great work when it comes to flying their drones into tornadoes. If you've never watched any videos of the Otis project, definitely highly recommend you watch videos of the Otis project. So, yes, so very, very great stuff that Otis does there. So, but thank you guys for letting me know that. Thank you. So yeah. So to get back on topic here, so again, it's Doppler radar, right? You will see the TVS, and the TVS will come from velocity. That's where we will see that tornado vortex signature come at. So it's also called gate-to-gate shear, things of that nature. What we're looking at that couplet. That is called that velocity couplet, which you can also call it gate-to-gate shear as well. So again, that's going to be right here in the section. So, and that is so that's very, very good that we do have velocity to help us see what are called velocity couplets, to be able to have that TVS, because again, reflectivity is not going to tell you if a tornado was on the ground. A velocity is just going to show you the hook, and reflectivity is just going to show you the hook, but reflectivity will not give you any TVS. So the TVS is what comes from velocity, from the velocity scan. And that's going to be green coming towards the radar and red going away from the radar. So remember, green towards, red away. So so that's what we look at to make that to that's what we look at to see that kind of circular motion there. We look at how the winds are coming at the radar, look at how the winds are going away from the radar, and then we can get that gate to gate shear for that. So but let's move on from that. So hook echo, I think a lot of us know what the hook echo is. That is a little pendant that sticks out from from the storm. And as you can see, it's defined here again on the southwest side of the storm. So, and that is where you're going to find the hook echo at when it comes to that. Libby says they do great stuff. Yes, Otis Project does excellent work. And again, if you guys have not ever seen Otis Project type videos, they are on YouTube. I also believe that they are part of Max Velocities. I know he does. He does show them on his streams, so I am. They might be part of his group as well. But besides that, it's very, very good stuff. So we just talk a little bit more as we can see the hook echo here, and again we can see the TVS located right here inside of it. How we can see the winds going in opposite directions of each other. So very great stuff when it comes to seeing. That's how tornadoes are seen on the radar. Reflectivity will show the hook, the pendant, and velocity can confirm that tornado with velocity couplet with a TVS. So that is how it gets paired up and married together. The images are, the NWS is pairing up and marrying those images together. So it's very great stuff when it comes to that. So any questions, any comments, any concerns, anything I did not point out that maybe you would like to point out, anything that you would like to understand or talk about that. So, but please let me know if you have any questions regarding on how tornadoes are pretty much confirmed by radar. So by using the TVS with the velocity. So when it comes to radar imagery. And again, we can thank algorithms for that, for helping us. So, and you guys are all awesome. You guys are all amazing. You guys are definitely rock stars. But again, let me know if you have any questions or anything else that you can point out, that you want to point out, or that you want to learn about. So, when it comes to learning about reading the radar for that. So, but again, great information. So with that being said, we will move on to tornado forecasting. So, how do we forecast it? How do tornadoes get forecasted to even begin with? How is that even possible to begin with? So, meteorologists at the NOAA Storm Prediction Center, or we like to shorten it and call it the SPC, issue daily forecast, or what are known as convective outlooks. And the convective outlooks, which we will take a look at here shortly, here in a little bit. Take a look at the convective outlook and see what the outlook looks like for today. So we definitely want to take a look at that to see if Brother John is going to be out chasing today, and if he is, where he's going to be possibly set up at and chasing storms today. So again, remember that the Storm Prediction Center here in the United States are the ones who issue the watches and they're the ones who issue the outlooks. They are not the ones who issue warnings. They do not issue severe thunderstorm warnings. They do not issue tornado warnings. Those come from what are called the local WFOs, the local weather forecasting offices. Those are the ones who issue the tornado warnings. And they all have a certified weather area that they cover. And so sometimes when you look on, you'll see a polygon and it'll look. So what happens is a lot of times. So if you ever see a polygon that looks weird, it looks like it's like halfway cut off, or it just looks strange, like it doesn't like it'll. A lot of times that's because a certain weather forecasting office can only put that polygon out to within its certified weather area. So if they want to extend that polygon onto another county, but it's not part of their a CWA authority, they have to work with the other WFO office, and the other WFO office has to extend that polygon. So sometimes when you see those polygons on the map, on the radars and on the map and the warnings, and you go, that looks like a really funky looking. That is because a lot of times they have to work in conjunction with. That's two weather offices. They have to work in conjunction, and the other WFO just has not caught up, and it just has not issued and extended that warning out. So Libby says, this may seem like a strange question, but do all radars run on the same rotation? As far as I know, yes, they all spin in the same direction. They all rotate in the same direction in order to maintain uniformity and conformity. So that is the best that I have seen research, is that they all spin in the same direction. Meaning, are their beams all pointing the same direction at the same time? Yes. So this goes back to what I know. If somebody else knows something, please put it in the comments. But it's to the best of my knowledge, they all spin in the same direction, and that is to help with overlapping coverage. And if you look on a map and you see two different sites. If you look at two different sites, two different weather sites, a lot of times if you do have if you're able to see their scan patterns, the way that they scan, they will scan in a full circle, what I know, in the same direction. So yeah, but they overlap. So one weather forecasting office will overlap. It's because they're usually they're like 200 to about 230 miles of a radius. So a lot of times you'll have weather forecasting offices within inside that radius that can expand out. So that's why when a certain radar site would go down, there's one close by that can be utilized and to be able to see storms and things of that nature. So yes, as far as I know, they all spin in the same direction. And again, that is for uniformity, and that is for conformity to the system that is set up in place. So that's how I know it to be. Libby says, like the polygon with a tail that was in Indiana or Illinois a month ago or so ago. I don't recall that offhand, but probably that most likely would have been why, is because once one WFO, they put out the warning, they could only go up to that county line, and they would need the other WFOs to step in and extend that warning. And sometimes that takes a couple of minutes. Sometimes the county won't do it. Sometimes the other WFO won't do it. So sometimes that's why the polygons look very funky at times. But again, we will get into quite a bit where we have to work in conjunction with multiple WFOs. So Libby says, great, thanks. You're welcome, Libby. And again, that's to the best of to the best of my knowledge, but again, I could be wrong on that. And if I am, I would love to be told exactly what that does. What they do as well. But again, to the best of my knowledge, that's what it looks like. So um, when it comes to that, so again, so forecasting, to get back into the forecasting, just so we know this, so we are fully all on the same page and we are all fully aware what the SBC does. The SBC issues the watches. The SBC issues the convective outlooks. So that's their job. Their job is to always constantly be looking at what storms. And again, that's what the SBC is. It's the Storm Prediction Center. And again, the big word in there is prediction. And as we know, to predict anything is absolutely impossible. We can't predict the future. We can't predict what we're going to do a minute from now. We can't predict what's going to happen. So that's the big word, is prediction. So again, the SBC is issuing watches and they're doing outlooks. So they also closely monitor areas that they think are at higher risk for tornadoes. Yes, they do. So if that's what they're doing, they are honing in on places where they think are going to be the most severe at. That's what their job is to do as well, is to help warn us of anything that's going to be going on severe wise or that nature. So absolutely. If conditions develop that are favorable for tornadoes, SBC forecasters issue a severe thunderstorm or tornado watch, and they do. So that typically lasts for 4 to 6 hours. So if you guys were ever wondering how long a tornado or a severe thunderstorm watch typically lasts, obviously they last, more than this, obviously, but the average tornado watch, an average thunderstorm watch, lasts about 4 to 6 hours. Local forecast offices, emergency managers, storm spotters, and the general public are alerted to the possibility of severe weather. So once the SBC puts into motion the severe thunderstorm watch, that gets broadcast to everybody. That gets broadcast to the local forecasting office. That gets broadcast to media. That gets broadcast to storm spotters, emergency managers, and all of the public. But that is not public knowledge until they fully put that out until they put out that emergency alert bulletin. So, and as I mentioned here, tornado warnings are issued by the local National Weather Service Forecasting Office. So again, tornado warnings come from the local WFO. When a tornado has been sighted or indicated by weather radar, people in the warning area should seek appropriate shelter immediately. So again, that's how it all ties in. That's how the forecasting goes. It starts at a high level. With the SPC, and then inside the SPC comes the local forecasting offices. So that's what is taking place when they are tornado forecasting. But it all starts with the SPC. That's what their job is. That's what they're there for. They are there to keep us safe and keep us alerted, and they do an excellent job at what they do. Are they perfect? No, but none of us are perfect. Are they going to get things wrong? Yes. And why is that? Because it's forecasting. That's in the description. It's forecasting. Forecasting is never 100% correct, and they are only utilizing the tools that they have to be able to forecast. We will never be able to forecast 100% correctly the weather. It's just not possible. It's not going to happen. We can have all the tools and all the resources and everything else, but you just won't be able to forecast the weather. Just like you want to try to forecast sales. Like if you have a business and you're trying to forecast sales for the next quarter, or you're trying to forecast sales for the next 6 months. You might be able to use, historical data and be able to use current data as well, such as sales orders and things of that nature. But at the end of the day, when you try to forecast what you're going to have happen in the next 3, 6 months, whatever it is, as a business, you will never, ever be able to forecast 100% correctly when it comes to that. Just like forecasting for weather, you just won't be able to do it. However, you would do it to the best of your abilities, and you would do it to the best that you can with the tools and the resources that you have at your disposal. You will utilize the tools and resources that you have at your disposal. So, again, forecasting is exactly forecasting. It is predicting, and as we know, we cannot predict the future. It's not possible. We're not God. We don't know what the future holds and what it looks like. And remember, weather is created by God. It is, since it is created by God, and the weather is greater than us. So, as God is greater than us. So, what does that all mean, though? Again, just utilize the tools that we have, but give the National Weather Service, the SPC, some grace. Some grace when it comes to when they miss forecasts. Give them some grace when it comes to weather bust days. Give them some grace when it comes to that, because if you were a forecaster and you're utilizing the best tools and the best resources that you have, and you put out a bust, you're going to want people to offer some grace to you. So again, just like you're going to want some grace when you make mistakes. So yes. So again, it's forecasting. It's never going to be 100% correct when it comes to that. So again, SPC, it all starts with the SPC doing the watches and the outlooks. They also the discussions and things of that nature, and then it flows inside into the local weather forecasting office to give us the warnings. So that's how it's passed off. So when it comes to that, so great stuff when it comes to the forecasting. Then we get into a little bit about computer forecasting models, and I think we've all have seen a lot of computer forecasting models. That would be like the NAM, North American model. That would be the HRRR. There's a Euro model. There's the RAP model. There are so many different models that are out there, but those are used to help in, again, tools and resources to help us best forecast tornadoes and forecast severe weather or any type of weather. So again, computer forecast models do aid in forecasting tornadoes. Ensemble, pretty much the same thing. It's computer models. Computer models work great if the weather follows the rules we have set. So when the weather breaks the rules, the predictions have trouble too. So again, things are put into algorithms, things are put into mathematical equations, things are put into run in order, and things are set, they're preset. And again, computer models work great when weather follows this pattern. But as we know, weather has a mind of its own and does what it wants. So again, so models, that's why when you look at certain models and you look at certain things, again, if you look at the HRRR, and the HRRR brings you back, 18Z or 17Z, or whenever the forecast comes, a model comes through, and it's showing storms are going to fire, to the west of Oklahoma City. That's what they're saying is going to happen at the HRRR. But when it comes to 17Z or whatever time that you're looking at on that, and you go, where the heck are these storms at? HRRR said it was going to fire her off to the west. And then you look at your model, and now the updated model is now showing the storms firing off to the east of Oklahoma City by about 30 miles. That's because you just don't ever know if they're going to fire up, and two, where they're going to fire up. So yes, computer modeling does aid in a lot of help with that, but just know it's not perfect of where it's going to set up at. So again, it's great to understand that these models do help, but they are not a perfect help. So just always be aware of that. If you are into computer models, if you are into different types of radar and things of that nature, just know that it's all put in there with algorithms, put in there by humans who have finite minds, and again, trying to spit out the best information possible. So when it comes to that, just know it's not going to be correct, and that it is just utilized to the best that we can to utilize that. So, everybody, welcome in. Lisa Peterson is in here. Thank you so much, Sister Lisa, for being here. Thank you for being a great encourager. Thank you for being a great supporter. Thank you for being a sister in Christ, number one. That's the number one thing. So thank you for being here. Appreciate that. Thank you for the people who are still watching on Twitch. Thank you to the people who are watching on YouTube. Thank you to the people who are watching on Facebook. Thank you to the people who are watching on Kick. So if you are new here, please like and please subscribe. Please, it helps me. So whether you are on Twitch, whether you're on YouTube, whether you're on Facebook, whether you are on Kick, please, please like, please follow, please subscribe, and please help me reach as many people as I possibly can on these cross platforms. So, so again, if you're new here, thank you for that, and also to everybody who is, normals here, people who are regulars here. Just thank you so much. But as you can see, if you're just joining, as you can see, I am multi-streaming to Twitch, multi-streaming to Facebook, and multi-streaming to Kick and YouTube. So 4 multi-streams today. So very, very thankful and very, very blessed for that. So again, what did we learn from this page? What did we learn from this section? This section just is that we're learning is the forecasting when it comes to tornado forecasting. It is used. There's a lot of data. There's a lot of historical data. There's a lot of algorithms. There's a lot of there's a lot of AI now involved in it. So there's a lot of different data and data sets and data mining and everything else that's put into place. And then these models run, and these models go, okay, now we're going to spit out what these models have learned and what these models have programmed to do. But again, the models are not always correct. So, but the SPC, again, what we learned, the SPC is the issuing authority when it comes to tornado watches, severe thunderstorm watches, convective outlooks, and discussions and things of that nature. So, and again, offer them some grace when they get it wrong, because they will get it wrong. Give them some grace because they are doing their best job when it comes to issuing things for us to keep us safe. And so yes, give them some grace because they will make mistakes. And just like, again, when I make mistakes and you make mistakes, we definitely want people to offer us grace as well. So great with tornado forecasting when it comes to that. It's a great, again, computer models, ensemble forecasting, So that is a lot of how. So we talked about, so to recap a little bit, we've talked about tornado formation, tornadogenesis. We've talked about the fact that we can't, or that we don't know scientifically, we don't know about how to that we can't fully predict tornadoes. We don't really know how they form exactly. But we talked a lot about, the 4 main ingredients that we need, right? We use that SLIM method, the SLIM model. And that SLIM, is again, it's shear, it's lift, it's instability, and it's moisture. So again, so you can use that SLIM acronym. So the 4 basic ingredients that you need for tornadogenesis, just like if you were baking a pie or baking a cake or baking whatever, we need shear, we need lift, we need instability, and we need moisture. So those 4 are the main 4 key ingredients to tornadogenesis. So now I want to take us from more of this topic approach teaching to a little bit about some record, some tornado records that you guys may or may not know about. So we'll take a look at that. We'll take a look at just some cool facts about tornadoes that you guys again may or may not know about when it comes to that. So it's very it's very awesome for that. So uh awesome. Thank you Lisa for commenting on Kick. Thank you very much. Appreciate that. Thank you so much. Uh appreciate that. So and these are going to be some pretty cool facts, I think. So, like I said, some of you guys might already know this, some of you may not, but to me, I find them very, very cool. So, when it comes to that, so looks like we got a Twitch. Oh, somebody from Twitch. We got somebody from Twitch. Thank you so much, Alora, Janny. Thank you so much. I am great. How are you? Thank you for being here. Thank you for tuning in on Twitch. So thank you so much for that. And we got Lisa. We got Lisa following now on Kick. Thank you so much. So thank you. Yeah, so thank you so much. So thank you, Alora for being here. Thank you so much. But yes, if you have any questions about tornadoes or anything like that, please feel free to ask, and do my best to answer those questions for you. But again, so thank you very much, Alora, or hopefully I'm saying that correctly, for commenting on Twitch. Thank you so much. Appreciate that very, very, very much. So. Thank you, Lisa. Again, Lisa, very awesome. Thank you for following on Kick, and as well, please follow me on Twitch as well if you guys haven't yet, and follow me on Kick and Facebook. I have to use my main account for Facebook right now because I have to have 100 followers for my brand page. So working on getting my brand page up to 100 followers, and then I can stream to that page. But right now, I am currently streaming to my main profile page on Facebook. So looking forward to getting 100 followers again on my John Boy 777 brand page on Facebook. But cool stuff. So let's move in to the facts here and get some cool stuff going here. So some of this, again, you guys may know. Some of this you may not when it comes to this. So this has actually been updated. So what you're reading here is actually not fully correct. But the fastest wind speeds observed in a tornado was during the F5, which is technically an EF5 now. Thank you, Marbella, for subscribing. Thank you so much, and welcome to the family. Thank you so much. Making my way quickly and blissfully towards 2,200 subscribers on YouTube. So very blessed for that. Very blessed for all of you. But so again, the EF5, you can say it's an EF5. It's still okay to say it's an F5. Was a Bridge Creek tornado, which we know pretty much shattered records that day when it happened. So, but at the time, it was measured at 302. This has actually been updated. So it is actually the fastest wind speed ever measured in a tornado. So if anybody ever asks you what is the fastest wind speeds ever confirmed and that the NWS uses, it's actually 321 miles. So they went back and recalculated this a few years back, and it actually is 321. So the fastest wind speed from a tornado that is confirmed and that is used in by the NWS is the 321 miles per hour by the Bridge Creek Oklahoma tornado. So thank you so much, Alonzo, too, for subscribing. Thank you. Appreciate that. Thank you so much. That is a huge blessing. Looks like they came in together. So it looks like Lisa also followed on Twitch as well. So thank you so much, Lisa, for following on Twitch. Thank you. You are definitely a dear sister in Christ. Definitely appreciate your support for that. So again, um, again, the the fastest wind speeds in a tornado ever measured is actually 321. So just remember that that is extremely fast when it comes to that. So the longest damage path, and some of you may know this, some of you may not. And if you do, great. If not, that is awesome as well. The longest damage path and duration by a single tornado belongs to the tri-state tornado. So if you're not familiar with the tri-state tornado, we have to go back all the way, and I might get this wrong. I'm just going off the top of my head. I believe it was 1925, if I'm not mistaken. That was a tri-state tornado. Somebody can chime in and in the comments here and let me know. But just going off of memory, I believe it was 1925. So long before we had radars, long before we had, or it might have even been before 1925. It might have been 1915-ish, somewhere around that section, somewhere around in there. For some reason, 1925 is sticking out. But nonetheless, that was long before we had radar. That was long before we had any type of instruments to help us, anything like that. So it had a path length of, and it's kind of disputed, but what is most likely, what is usually accepted is the 235 mile an hour, or is a 235 mile path. That is usually accepted. So the tri-state tornado is the longest long-tracked tornado in U.S. history. And they say it lasted 3.5 hours. So when it traveled for 3.5 hours. So that is a very long time for one tornado to be on the ground. And again, it's widely accepted that it traveled for about 235 miles before it lifted. So that is a long way. If you look on the map, that would probably be, that is basically about Chicago headed west, close to getting to like getting close, not as far, but close to the Des Moines area and things of that nature. So pretty far out to the west. If you did a straight line from Chicago out to the west there, so pretty far. But yes, when it comes to that, so Libby says yes, 1925. So I'm glad I got that right off my head. So, but yeah, and I do believe it also had a end up, and we'll talk about it here. But it was moving pretty quickly as well. And somebody correct me if I'm wrong. I'm going off of memory. I believe it was Illinois. What was it? Was it a little bit of Missouri into Illinois into Indiana? Somebody correct me if I'm wrong, but I think that's why it's called the tri-state. I could be wrong on the Missouri part, but I'm pretty sure it was definitely Illinois and Indiana was part of that. So, but again, I could be wrong, so somebody please correct me if I am wrong on that. So, what else do we get into? We get into what is the deadliest tornado in the world? The deadliest that is known, that is documented, the deadliest tornado in the world belongs to, and I'm not going to be able to say that correctly, but it's in Bangladesh, and it was in 1989. It was in 1989, and let's see, and it unfortunately it killed approximately 1,300 people. That is wild, and that's sad, and that is super unfortunate. It left 80,000 people homeless and injured 12,000. So if you were here in the beginning, and thank you so much if you were here in the beginning when I started streaming, when we started getting into some of the great information. If you remember, Bangladesh is a hot spot. So outside of the United States, there is Argentina and Bangladesh happen to be pretty much the other two hot spots outside of the United States. So So if you remember that, here's Bangladesh right here. So um, moving on to the next bullet point. The most extensive tornado outbreak was 2011. Now, sometimes this also gets 2011, sometimes also gets put in with 1974 outbreak. So sometimes some people will say the 1974 outbreak was greater than 2011. I guess it just all depends on your subjectivity to that. Some will say, well, 2011 Someone say the 2011 was greater because maybe it was the largest, costliest, things of that. But nonetheless, whether it's 1974 or 2011, just know that those were huge outbreaks. And if you can pretty much do the math on that from 74 to 2011, that's basically about a 37-year stretch. So those are what are called once in a generational type of events. So we have 74, we have 2011, and if we go just kind of off of that, since weather does repeat itself, it's possible that for us to have another weather event here within the next let's say this is 26, so we're 15 years into that, maybe within another 10 or 15 years or so, or we could have one next year. You just never know. But if we're going based off of just weather repeating itself and outbreaks such as that, those outbreaks like that are usually once in a generation. So, but again, you never know. The most damaging tornado adjusted in wealth and inflation was the 1896 East St. Louis tornado on May 27th, 1896. It caused over $10 million in damage in 1986 or 1896, or nowadays, or actually that's even a long time ago. That's back at 4.45 billion, which would be even more in 2026 money. So just some good information on that. And then we get to one of the most famous tornadoes ever. Thank you, Libby, for saying that I am correct. Thank you for that, as in regards to the tri-state tornado. Thank you so much for that. So as we get to the widest on record is the El Reno, Oklahoma tornado on May 31st, 2013. At its peak, it reached 2.6 miles. So the next time you drive 2.6 miles, like if you just start and you look at your odometer and you look, you start at one point and you look back up and down again, and it's at 2.6 miles. That's how wide that tornado was, which that is ridiculous. 2.6 miles coming, a pure devastation coming at you. That is absolutely insane to even think about. Another one is another wide tornado too is I believe it's called Bassfield Soso or something like that. That was down in Mississippi area. I believe it's Mississippi. That's another wide tornado. I think that's at like 2.2 or 2.3, 2.4, somewhere around in there. So that was another huge one, and that one happened I want to say in like 2020, 2021. So I think it's called the Bass Soso or Bass, something like that down there. But anyways, that's another wide one as well. So, but again, El Reno holds that record at 2.6 miles. And again, that was preliminary rated an EF5, downgraded to an EF3 because of that's the only damage that they found was the most devastating damage they found was EF3 wind speeds. But as we know, even the winds that were clocked inside of that, I believe the winds that they clocked inside of that were plus 300. I want to say about 310, 316, if I remember off the top of my head correctly. So again, had that wind speed, impacted structures at that time, it definitely would have got that EF5 rating for sure. So the highest forward speed of a tornado ever recorded was 73 miles per hour by the tri-state tornado. So again, not only was a tri-state tornado devastating, which record keeping back then does not go back, but people say that if the F5 scale or the EF5 scale was in place back then, that it would have received an EF5 rating. So imagine that type of tornado flying down, barreling down on you at 73 miles per hour. So that is in most states that is speeding, and that tornado would have received a ticket for speeding. So that tornado was not abiding by any type of laws at all. So again, in most interstates and in most states, that tornado was speeding. So here is a crazy fact that I find extremely, extremely fascinating. The longest distance a person carried by a tornado and has lived to tell about it. So imagine you're sitting in your house or wherever you're at, and a tornado comes and picks you up, just carries you away, and you live to tell about it. So in recorded history, the longest distance a person carried by a tornado and lived belongs to Matt Suter of Fordland, Missouri. He was sucked up out of his mobile home and was carried 1,307 feet. So when you do the math on that, he was carried about roughly about a quarter mile. So imagine you're sitting there, you're in your house, and the tornado comes and carries you a quarter mile down the road and drops you back down and spits you out. And thankfully you live to tell about that. So again, it is so that happened on March 6th, 2006, and that tornado was rated an EF2. So imagine if that tornado was rated even higher. Imagine if it had higher wind speeds, it would have carried them even further. So I find that very fascinating. So that is very wild to me. But great thing that Matt Suter obviously lived to tell about that. So just a wild fact. It's a wild fact that you'd be sitting in your house, and the next thing you know, you are being carried about a quarter mile down the road from that tornado. So very wild. And to finish off the last bullet point, the costliest tornado in recent history was Joplin, 2011. So Libby has a great question. Libby says, was he aware during the flight and able to tell stories? So from what I know of the story, Libby, is that I know from what I've looked up in research is that he was unconscious. So I think he was unconscious during the flight because he was found unconscious in the when they found him in the field. So it threw him in the field. It laid him down in a field a quarter mile, like I said, down the road. So as far as I know, I don't know if he has any recollection or if he was aware during what was happening. I do know he was found unconscious when they found him. So, and then when they asked him where he was at, they asked him where he came from, whatever, he explained and told them, hey, my house is, a quarter mile up the road. So how the heck did I get here where I am at? But yeah, that would be a great thing to know. But as far as I know, I think he was already unconscious. I think from what I know, I think it smashed into his trailer. And I think when it smashed into it, it knocked him out. And then when it knocked him out, it picked him up and tossed him. So yeah, and Libby says, that's what I was going to guess because of the barometric pressure. Yeah, for sure, because I'm sure that pressure dropped immensely with that tornado right over on top of him, for sure. But I do know that he was knocked out somehow. So, but yes, but great question. Awesome question, Libby. You always have great questions, so awesome. Debbie says, you should always be prepared for tornadoes when they strike. Look for a storm shelter. Mobile homes are not good for bad storms. They don't have good shelters. Absolutely. Mobile homes, and they will tell you, mobile homes are the worst spots to be in if there is a tornado approaching they will actually tell you to get of out of your mobile home and go somewhere sturdy if you can, or try your best. And I know it's kind of sounds like but to get out of the way of that tornado somehow, go in a ditch. But they say the worst spot to be in is to be in a mobile home. So, and you can understand why. Because why is that? Well, because of many reasons. One, they're not very structurally sound built. But two, then one of the main reason is that because they are off of the ground. They are usually on wheels, like you see a semi trailer going down the highway. So what happens when that wind comes in? That wind just sweeps right underneath that trailer and just absolutely obliterates it. So again, they're not very structurally built. They're not very structurally sound. They're not tied down to anchors. They're not tied down to a foundation. And the wind just comes in and just completely annihilates it and obliterates it because the wind can get underneath it so quickly. So that is why they will tell you a lot. If you are in a trailer or a modular home or whatever, do your best to get uh, out of that situation. So very great point though. But yeah, I think that was just for Matt Suter. That is a wild thing to tell people, is to say, hey, I got picked and up by a tornado and thrown a quarter of a mile and lived to tell about it. So how awesome is that? That God protected him throughout that ordeal. Uh, so, but yes, but to move into the costliest tornado in recent history for us is the 2011 Joplin tornado. And if you guys are not familiar with that, it was a nightmare tornado, about the worst case scenario that could happen. Happened to strike a good sized populated city. Um, and it eventually, destroyed much of the town there, much of the city there. So again, if you ever see videos out of that, I highly recommend watching videos from that, just because of the how nasty and how dark that things got that day. Uh, and it was just complete a lot of annihilation for, unfortunately, a lot of residents there. So it took the hospital. I know it moved the hospital like 4 inches off of its whole foundation, and you're talking that's a huge structure. So the hospital pretty much took a direct hit, and the hospital ended up getting moved 4 inches off of its whole foundation, and then they ended up destroying and ended up demolishing the hospital sometime later because it wasn't able to be put back into operation. So again, again, uh, Joplin was very bad. And actually, yes, what Libby says here, Joplin was such a sad situation, and it completely was. There was people who had just kids who had just graduated high school. You had a lot of graduations going on. You had a graduation going on at that time. It really struck at like the worst time possible. I mean, it was I believe it was like right around 5 o'clock ish, maybe somewhere close to that time. So, um, and or maybe it was a little bit later. I can't remember exactly the time, but um, so not only did that happen, um, not only did that happen at the hospital, and like what just got pointed out here, could you? Yes. So not only did the hospital take a direct hit and get pushed off of its whole foundation. So could you imagine the whole freaking hospital takes a direct hit, and then you have to care for the people who are inside the hospital, then you have to care for the people who are coming to the hospital. So that was probably very, very traumatic for sure. When it comes to that, yes, and unfortunately, 158 lives were lost that day. Unfortunately, just a very, very tragic accident. There is a great video. If you guys ever see it, look it up. There's a great video that a guy posted. He was in a convenience store. And if you watch the video, uh, everybody ends up safe and sound, or everybody ends up alive, and they end up moving to a cooler. Where like cooler here in the U.S., we use coolers for like alcohol, things of that nature. It was an alcohol cooler as part of that convenience store. But if you ever watch that, um, if you ever go back and check out a video from that Joplin, definitely watch that video. It'll show you as that tornado approaches, it completely blows out and obliterates the convenience store's glass um, windows and everything like that. And then eventually they all move back into the cooler, and the cooler is what saves their lives. So, because besides that, they all would have been pretty much swept away when that whole building exploded. And so, yes, but he has inside photo or inside video of the cooler, of what it looked like when they were inside of that. And when he crawls out and he shows you all the devastation and all the damage around, you can see that it's just pretty amazing that they all survived in that cooler. So, but definitely Joplin was definitely a horrible situation. Um, it just completely happened at obviously at the wrong time. It happened just and it's just a really horrible, tragic situation. And another thing that goes in with Joplin is that there happened to be some airborne, because of how damaging it was and everything else, of all the spores that got into the air and all the bacteria and everything else. There was actually people who ended up unfortunately passing away from, I believe it was some sort of like fungus or something similar or something like along the lines of that got caught in the air and then spread out to different places throughout Joplin. Um, so that is definitely horrible, and that fact as well that got spread out there. So that is very very unfortunate when it comes to that. So, but again, Joplin, um, very 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 sad situation. Very very when it comes to that. So yeah, so a lot of just a lot of great information, a lot of great records there when it comes to tornadoes. Just understanding the records. I mean, not great in the sense of what's happened, but just knowing. Unfortunately, like the wind speed, the widest, how many we get a year. We get about 1,200 here in the United States. So things of that nature when it comes to that. So it's just good to understand that. And we also discussed the EF scale. Able to walk you guys through the EF scale, why the EF scale is in place, how it's in place now, and what it's used for now. So, um, when it comes to that, but definitely, definitely a lot of great information for tornadoes. Again, just to briefly recap is we don't know how they form, but we do know the ingredients that are needed for them to form, um, and what structure to look for on radar, the tornadogenesis that goes inside of tornadoes, what's happening there in the atmosphere, things like that. And again, you don't know if a tornado plants down. You don't know exactly the strength that tornado is going to be. So, yes, the NWS does have certain parameters in place, and they think that sometimes there might be some atmospheric conditions in place, and they believe, hey, the max tornado today is only going to can reach, EF3 level or whatever it may be, but that is not always the case. So, again, just know that when a tornado plants, you don't really fully know what size or what strength that tornado is going to be. So yes, Libby says, and Libby makes a great point here. An excellent point, Libby. Thank you for pointing that out. The mental shock of the visual changes from before to after is enough to cause some mental health issues. 100%. So could you imagine, you know, just 10 minutes before all that, and, you're at high school graduation, and then the next thing you know, your whole high school is destroyed. You're seeing, and I'm just talking about that, but I mean, just everybody else too. Imagine seeing all the devastation and seeing all that when just, 5, 10 minutes before all that, everything was standing. So definitely, I would definitely say that that caused a lot of mental health issues inside of Joplin, because not only that, seeing that, then obviously people probably having friends and family that unfortunately passed away that day. But definitely, yes, just definitely seeing the images would definitely be shocking to say the least. Um, so I mean, people gawk at EF0 and EF1 damage. Imagine seeing EF5 damage spread throughout pretty much your whole town. So yes, definitely, Libby, great point out there when it comes to that. Definitely great for that. So but yeah, so that is basically the recap of what we have learned today. The topic again, if you're new here, again, this is I like to coach and teach on weather phenomenon or any type of weather. Um, so definitely teaching. So at the beginning of my streams, I will teach on the topic, and then we will jump into some fireside chats and just talk about anything and everything that we find fun to talk about and things of that nature. But again, I think we are all of us are very driven and very weather aware and weather just enthusiast and kind of just in awe of God's power, and especially when it comes to tornadoes for sure, because them being the most destructive phenomenon that there is on Earth. So, but if you're new here, again, please follow, please like, please subscribe. Um, Again, I am live streaming across 4 different platforms: Twitch, YouTube, Facebook, and Kick. So, again, very, very thankful for the opportunity. Just setting everything up and learning all of this multi streaming. So, uh, it is definitely a lot more um, challenging to multi stream as compared to just streaming to one platform. But I think it's going pretty good right now. So, but again, that is how I do my sessions, my weather teachings. And I know today is was an earlier session, was an earlier type of seminar. But again, today I wanted to try out the multi streaming, and so really wanted to jump in earlier in the daytime just to kind of see and get a feel really where my audience is, coming from. So maybe some of my audience might be late night folks, some of my audience might be earlier, some of them might be middle of the day. So you don't know until you try. And but very good stuff. So again, that's the topic again today of Tornadogenesis. Some pretty cool or some pretty interesting facts when it comes to tornadoes. And just learning sort of more about how tornadoes get forecasted, who does the forecasting for tornadoes, so things like that. So hopefully it's been very insightful so far. If you are enjoying still, please give me a thumbs up, or just let me know that you are enjoying. And if you're not enjoying, I appreciate you being here as well. I cannot please everybody. So again, if I missed anything, or if you have any information to add, please do. But let's jump into the Q&A side of things, and let's jump into questions, comments, concerns, any cool thing you want to talk about. But let's jump in here. When it comes to just jump into having a cool, good fireside chat here. So, but yeah, so any type of questions, anything you want to point out about tornadoes, that are just that you find fascinating, anything you want to talk about, let's talk about it, and let's learn from each other. So, but yeah, if there's maybe a particular favorite, I shouldn't say favorite, but a particular tornado that stands out in your mind, a particular, anything like that, let's talk and discuss. Uh, but yeah, but any questions when it comes to anything else like that? And just, yeah, let's talk and let's talk about it. So, but yes, I am very fascinated, and I can start first and say why I'm fascinated about tornadoes. I'm fascinated about tornadoes just by their sheer power of that. So, um, Libby says, I may have missed your telling us previously, but what inspired your interest in weather? Great question, Libby. Appreciate that. Thank you. I can remember being, and I will get to that in a second, Libby. Thank you for subscribing, Edgar. Thank you so much. Appreciate that. Thank you for being here. Thank you for your subscription. Thank you for subscribing. Appreciate that. Uh, but yes, but Libby, to answer your question, I can remember being as a young man, young kid. I think I can remember back like maybe like 5, 6, 7 years old, just being very, very just enthusiastic about weather, like wanting to learn and being what do you want to call it, like inquisitive. And so I think it kind of goes back to that, and then just seeing a lot, um, like watching the Weather Channel a lot. Um, I think experiencing that, as a young age. So I just have really been interested in that um, at a young age. I just have always been interested with that. I guess there's really really no like uh, per se rhyme or reason. I think I just have always loved that. That along with sports as well. But when it comes to weather, yes, definitely, that's what has driven piqued my interest from a young kid, and then just as I've continued to get older, continue to learn new things and and continue to pique my interest in different things. From the scientific side of things to the climate side of things, climatology side of things, meteorology side of things, just like things like that. But yeah, so definitely fascinated by that. Fascinated by radar. Fascinated by tornadoes. And again, my fascination has always been with severe weather, with tornadoes, severe thunderstorms, things like that. That's a lot of where my interest comes, and that's where a lot of my enthusiasm comes from. So yes, I guess I think, and this is what I'll get into, and again I'll share a little bit about my enthusiasm for tornadoes. Is that I just am in awe of their um, true power, all of their sheer power, right? Of what they can do. Just the fact that we can't control them. We don't know when they're going to happen. So I just am just in awe of that whole kind of story wrapped around them. Why they do certain things, why are some of them multi vortex and why are them single vortex? Why can they hit one house and then leave the house, you know, next to it standing, but it wipes out another house right next to it, or wipes out the house that it hit. There's just certain things that I've always been extremely highly, highly fascinated by tornadoes. I don't know. I just have this passion and enthusiasm for tornadoes, and so I just started studying them and paths and way they move and just different things. So I just have taken that and run with that. So that is what has piqued my curiosity, is just the sheer power of them, but just how why does one storm put one down, and why does another storm not put one down? So um, Libby says, I think they give us the opportunity to see the power of God and His grace. Absolutely. Very great point out there, Libby. Absolutely. That is wonderfully said. Definitely. But yeah, think about how just just I mean, think about it. I mean, if you were that Matt Suter guy, right, and you got picked up a half mile and dropped in a field, and you live to tell about it. I mean, think about how powerful that story is, right? And there are other stories out there too of people being picked up and and thrown, just not as far as he's gone. Well, that's been documented, uh, but definitely besides that, I mean, they're so never is one tornado the same. They're all different, right? They act differently, they think differently, they move differently, um, and that's I think is what is they all inspiring to me. Is it's just like the power behind it, the the mystery, the mystery behind them, because they're all mysteries, right? They're all like, okay, all these ingredients had to come together, and it and it produced a tornado and stuff like that. But a lot of times, all those ingredients will come together, and they won't produce a tornado. So again, it's to me, it's the mystery, it's the power, it's I don't like to. I don't know if beauty is the right word. I guess their beauty, the beauty of it is when they're not hurting people and they're not hurting, hurting property and things of that nature. But there is beauty in it. There is beauty in tornadoes when it comes to that. So uh, but that's fine. But that's I guess that's what's always piqued my interest, and it continues to always pique my interest and pique my enthusiasm and keep me just very just very involved into them and everything. So, but I definitely would love to learn why you guys are enthusiastic about tornadoes. What what why is it you enthusiastic about storm chasing? Why are you enthusiastic about severe weather? Learning about severe weather, learning about weather. What is it? Because everybody has different reasons for why they enjoy it for, or why they're enthusiastic about it for. So please let me know in the comments what why you are a weather buff for, and if you consider yourself a weather buff. Do you consider yourself a weather buff? Are you just a fan of the weather? What it is. So definitely would like to know that for sure. So when it comes to that, so very thankful again still for who's for people on Twitch watching, people on Kick watching, people on Facebook watching, and people on YouTube watching. Thank you so much for everybody who was here across the multi stream. Thank you so much. Libby says there is a beauty to them, even though it is saddening about the damage and injuries. Yes, there is absolutely, but there is definitely beauty in just there's just something like I get like the mystery, majestic. I don't know if majestic's the right word. There's just something that is to me. I just find like I'm just gravitated towards that, and it's like so it's in but I think it's too. I understand that. I understand the raw power of them, and just how violent they can be, and so respect, right? You have to respect that. But yeah, so definitely when it comes to that, but definitely want to again open this up for any type of questions, anything, anything, you know, tornado, weather, anything you want to talk about, any type of questions when it comes to that. But again, we are all family here. We all are learning together and from each other. So I'm very blessed to do this for you guys, and I'm very blessed to have you guys help me learn as well when it comes to that. So very blessed for all of you. You all are amazing, all of you, and it's just very cool to see all of you in here, and so it's very cool. But yes, so let's do a little bit of questions here, and then once we do that a little bit, I'd like to we'll jump on over to. Well, actually, we'll wait here. We will wait here for till about 1 o'clock, because 1 o'clock is when the well, not 1 o'clock. I'm sorry. That should have been out at what before 11:30. So actually, I'm sorry. So actually, it's already up the outlook. The current outlook is up. So let's go into. Thank you, Debbie, so much. I appreciate you, Debbie. And like I said, hopefully your brother is doing well. And the medicine you said that he was starting to take for his vertigo, I hope that is helping him out as well. So prayers for him and prayers and love for him. So yeah, so let's jump into let's look at the current outlook and see what the NWS is telling us for today. So okay. So we do have a enhanced area today, which is pretty close to where Brother John is at. So I'm assuming that Brother John is going to be out chasing today, which is going to be awesome. Before I get into the NWS here, I will get into what Libby says. Libby says, I was about 3 years old. I was about 3 years old and very afraid of storms, mainly because of the volume of thunder. I would sob and sob, but my mom told me about the psalm about God's voice thundering, and the fear ended. Awesome. That is very awesome. Thank you, Libby, for that. That is so cool. That is a great story. That is a very, very awesome to hear. Very comforting. So definitely, I too, and this is what I think is really, really cool about the victory of. So I've always been into gravitated, to severe storms and tornadoes and everything. But I even into my mid-20s was very, very scared, very, very afraid of tornadoes. And what I want to say is I was petrified. Not at first I was afraid and then I was petrified, not like the song. I was always petrified, like scared, like irrationally scared, probably, but super, super petrified of tornadoes. So I would actually leave my house, which is not really a good thing to do, but I would actually go and be around, like, go to like a big box store, so like a Kohl's or a Walmart or a Meijer or something, and just so I felt more safe around people. I didn't feel safe even in my own home because I didn't have a basement. A lot of times I didn't have a basement. Uh, so a lot of times I would be like, okay, well, I don't have a basement. I don't feel safe here. I feel safer around people. So I was definitely afraid, petrified of tornadoes, and not just tornadoes, but storms, severe storms themselves. But thankfully, the good Lord healed me of that, and that is no longer the case. But yes, that was me even into my mid 20s. That I was definitely still petrified and still afraid of what was going on. So of severe storms. So I definitely can relate to you there, Libby, when it comes to that. So if we jump over to today, we jump over to the enhanced risk, and this should have got updated probably about 11:30ish, 11:12. Yeah, that makes about sense. And so if we look for today, what is driving the enhanced risk today? So if you look at that, what they're saying today is even though there is a enhanced risk over here, the tornado threat they're saying is up here. So they're not even saying that the tornado threat is down here today. But again, doesn't mean that it can't happen or won't happen, but they're saying that the tornado threat today is up here, Wisconsin, northern Iowa, and a little bit of Minnesota. So that means what is driving the severe weather for today, and that is going to be either wind or hail or both of them. So if we look at it, it looks like we have major wind threat today over in Brother John's area today. With a hatch, looks like a SIG 1. Yep, SIG 1. So a 31 so a 30% chance of damaging strong wind with the Sig 1 hatch right here. So again, this is driving the um, severe weather threat right there. So in hail, about a 5% hail chance, but again, it is all wind driven today. So that is what is driving. And if you want to learn a bit more into the synopsis and to more of the um, science behind the thing, they talk a lot about it here on the National Weather Service. So great things to get involved in and read their verbiage when it comes to how they put out the bulletins to the public. So again, enhanced is driven today by wind. So let's see if they have let's see if they're talking about any how strong the winds they're talking about if they have it mentioned here. So let's see. They're probably talking then. It's not mentioned. It probably with that, I would say like 70, 75 mile an hour or greater, most likely. So when it comes to that. So, but again, today is driven by wind. But you still cannot roll out a tornado depending on if the parameters are in place for that. So, but again, but yes, so it looks like Brother John will probably be out today. Not 100% sure. I know he did end his stream last night pretty late, but then again, that I'm pretty sure he will probably be out again running chasing storms today. So it's gonna be a great chase today for Brother John, and but again, today is driven by wind with a little bit of a 2% chance up around the for tornado up around this area. So so there might be some storm chasers that might be right up in here. So if there are any chasing out today, this is the vicinity they would most likely be. I don't know where Brother John finished at last night. Oh, he was in South Dakota, I believe. Yeah, so I don't know. I don't know if he's making a trek this way for the potential tornado chance, or if he just came back down home and just is playing the hail and playing the wind threat as well. So again, I do not know that, but obviously, whatever he does would be awesome, no matter what he does and what he chooses there. So, so it's very great stuff. That's what's looking like right now for today. And this outlook just came out again like an hour and a half ago. So so pretty good on that. So and then it won't be updated again until 3 o'clock my time. So 3 Central, 4 Eastern, 2 Mountain, and 1 Pacific is when it will get updated again. So good stuff on that. By the way, you all are awesome. Just want to let you guys always know that. The fact that I have 2,140 subscribers on YouTube is absolutely ridiculous. So thankful for that. I am getting. Debbie says John said yesterday he will be chasing it again today in Iowa. Okay, great. Okay, awesome. So he will be out here in this section then. So but definitely that's very cool. So if he did say that, this is where he's most likely going to be set up at, and is right around this area. So when it comes to that, but as I was saying, yes, very, very awesome. Thank you guys so much on from the YouTube side. Thank you everybody. You guys are awesome. I am getting very, very close to the watch hours needed to become a YouTube partner. I've already surpassed And thankfully to you guys, I've already surpassed the amount of subscribers I need, or that is needed in order to become a YouTube partner. And I'm getting very close to the watch hours needed to become a YouTube partner. So very, very excited for that. Very, very thankful for all that. And that is due to all of you. That is due um, because you guys are all awesome and you guys support me when you don't need to and when you don't have to. But I am very thankful for your guys' support and for your guys' just love and encouragement. You guys are so amazing and so awesome. And looks like we have Julie Rios in here. Thank you, Julie, for being here. Thank you, Julie. Looks like you are already getting a warm welcome. Thank you for being here, Julie. Thank you for again your support and your encouragement and everything. So, but again, you guys are awesome. Just very thankful. Again, you guys are so again, you guys are the main reason I am at where I'm at now. Progressing through this YouTube experience, progressing through this, and now putting more, gaining more experience now with Twitch and Kick and Facebook, and being able to multi-stream and to be able to reach as many people as I can through different platforms. Because again, I do this because I love to do it, and I'm just thankful that you guys happen to want to hear me talk about it and support me on that. And but again, my number one overarching goal, my overarching reach that I am doing is obviously is doing my best to spread the gospel, is doing my best to spread the word of Christ. It is to do what I can for him and do my best at it because I owe everything that I am and everything that I have to him. So while weather plays a big part in growing my platform, Christ obviously plays the largest part in growing my platform. So and again, people who will stick by me will through that and through all that are the ones who care the most and the ones who have my back and have my the support for me the most. So thank you guys, all obviously for that. But again, weather just plays a little part of my overall reaching goal. And but you guys, like I said, you guys are awesome. You guys are amazing. Again, if we jump back in to the NWS here, we jump back into the tornado threat, the wind. If we go look at my mouse is really functioning right now. If we look at come on. Yep. There you go. You can do it. All right. You can do it. You can do it. There we go. So it looks like tomorrow, right now, for the day 2, they have a slight risk out for tomorrow. So it looks like Brother John would probably be out again chasing tomorrow. So how cool is that? It's always awesome to see Brother John out chasing and to see his passion for chasing. He has such a great passion for chasing, such a great enthusiasm. But not only that, he's a great teacher as well. So if you ever see throughout, I call him Brother John and Pastor John as well. If you ever see throughout Pastor John's streams as well, he does a lot of teaching in those streams when it comes to radar and looking at certain different things. So not only are you watching a great stream about storm chasing, you are actually going to be learning some things as well, which to me is super awesome. So very, very cool when it comes to that. So very thankful when Pastor John is out there storm chasing. But not only that, another great reason, and and to me, it's the number one great reason is because Pastor John likes to give a little bit of a devotional, likes to give a little bit, talk about the Bible a little bit. So not only do you get the great knowledge and a little bit of a sermon from Pastor John, you get to also learn about storm chasing. So great stuff when it comes to that. So, but yes, what does it look like for tomorrow? Currently, look for tomorrow. Looks like we have a slight chance here. Let's look to see what's driving it. What is driving it? It is being driven by not tornadoes, but there is a tornado chance tomorrow. They have it currently again, and not in a spot that needs any more tornadoes. It is southern Illinois. And if you know anything about Illinois right now, Illinois has been completely ransacked by tornadoes this year. Completely ransacked by them. We have, and I say we because I live in Illinois, we have shattered our record, our yearly record for tornadoes, and we still have 5 months of the year left, so, or whatever. 6 months of the year left. I'm sorry. So we still have 6 months of the year left. So, so imagine that Illinois annihilated their yearly tornado record, and there's still 6 months to go. And so unfortunately, it looks like tomorrow there is a 2% chance for tornadoes down in southern Illinois. Not a good spot. But let's see, tomorrow is also probably driven by wind. Yep, it looks like a 15% wind tomorrow. And it looks like hail, maybe. Oh, there's a hatched hail way up in North Dakota. And it looks like Debbie says, I definitely agree, John Boy. Thank you for that, Debbie. Libby says it is fellowshipping storm chasing style. Yes, it is very cool. You get the best of both worlds when it comes to that. And then Julie Rio says 5 months. We are in July, correct? But we just completed 6 months. So like we're still in the beginning of our. So we go July, August, September, October, November, December. Still 6 months that are basically left because since we have not completed July yet. So, but yeah, so still basically 6 months of time to go for Illinois. So for everybody to get tornadoes, unfortunately. So, but yes, but when we look at that, when we look at for tomorrow, the hail got a hatched up there for up in North Dakota, wind 15%, and then tornado 2%. So right now, slight chance around Brother John's area again. So if we look at day three right now is currently at marginal. And day three, if you're not familiar with how the outlooks look, day 3 does not ever have a tornado outlook in it. It does not ever have a hail outlook in it, and it does not ever have a wind outlook in it. Only days 1 and day 2 are the ones that have those outlooks. So if you ever try to go look at a day 3, all it will have is categorical and probabilistic. So, and it's just saying probabilistic, a 5% chance of maybe a wind event, maybe a hail event, what it might be. So right now, but we don't know as we get closer in time, they will be able to dial that in more and then start coloring that in more if there needs to be colored in. So very cool stuff on that. So again, today, if we go back, today, driven that 2% there. And like what has been talked about in the chat, looks like Brother John is going to be possibly off in Iowa today. So maybe around Sister Lisa's area there. So how cool is that? If I pop on the cities here, it looks like the the outline is just north of Des Moines right now, but again, that can change and might and potentially probably will change throughout the day, possibly. So when it comes to that, so again, all great stuff, all great things there. So from that, so looking at that, I'm so if we back up, go to the NWS, and again, if you're not familiar with the outlooks, it also goes through days 4 through 8 as well as it looks out. So, but it looks like right now, it looks like the predictability is too low for every single day from day 4 through day 8 right now. But again, that can change and often does change. So, but very cool stuff. Very cool stuff with that. Very great stuff about tornadoes. Very cool stuff. Just learning, teaching you guys, and again, maybe it was some information that's been regurgitated or information you already knew. Hopefully, it was a little bit of new information that you did not know from that. So, but yeah, so very great stuff when it comes to that. It's very awesome. But again, if you have any questions, comments, let's let's fire away and ask away if you have any type of thing like that. In the meantime, thank you so much to the people watching on Twitch, to the people watching on Kick, to the folks watching on YouTube, and the folks watching on Facebook. Thank you so much. And again, if you just joined in, I put up a new graphic today that is shows about that talks and shows about the current warnings. So flood watches, flood warnings, tornado watches, tornado warnings. Just a way to it goes through the NWS warnings and that. So when it comes to that, so very cool stuff. Very great stuff to learn and to just kind of visually see. So, but very great stuff. Debbie says, I am good there, John Boy. Thank you so much, Debbie, for that. You are awesome. Thank you so much. Thank you, everybody. You guys have been great. You guys have been awesome. Yeah, but definitely, um, it's been again. This is just trial and error. Just streaming at different times and streaming at, again, different times and streaming to different platforms, and to growing that. But if you guys have any, like request or any type of feedback, anything to like help out, or anything to that you perhaps might think might help me in streaming or anything like that, I am all ears. I am open for all type of feedback and anything like that, because we are all family. We are all in this together, and we all learn from each other. But again, I am open to all requests and open to any types of feedback, anything like that. And also, again, let me mention, you can find the links to my profiles on Kick and Twitch and Facebook, or on in my profile page on YouTube here. But again, so please subscribe and follow if you guys do have Kick or Twitch, please do. If you do have that, appreciate that. So just looking to expand platform and expand my platform, expand my reach when it comes to that. So you guys are awesome, though. Hopefully you guys enjoyed this session. Hopefully you guys again picked up a little bit of the information that I was putting down and teaching, coaching, tutoring, whatever you want to call it. But very thankful for that. You guys are all amazing when it comes to that. So if we look again, so if we jump in to, if we go back to the main weather page, we can look at all of the um, active alerts all across the country here. Um, so we can look at that. We can look at radar. If we look at radar, uh, see if it's showing anything here. Let's see a little bit of showing. It is showing a little bit of convection here. So it looks like a little bit of convection here, maybe in Iowa, trying to come up, trying to take shape. So that again is a possibility to where the 2% chance of tornado chance is at. So it looks like we got a little bit trying to kick off here. A little bit here in northern Iowa, far western Wisconsin, and a little bit of southern Minnesota. So, uh, but yeah, thank you, Libby. I enjoy all of your sessions. I'm trying to catch up on the ones I missed. Thank you. Thank you so much for that, Libby. Definitely appreciate that. Uh, you are such a great supporter, such a great encourager, uh, very inquisitive, very just wanting to know um, more, and that is awesome. So definitely sharing your enthusiasm when it comes to weather, definitely for sure. So, um, and also too, while I'm thinking about it, it's on my mind. If you haven't yet, please, uh, if you haven't, please subscribe to. Although I think you're gonna need a link, but uh, so I'll have to get a link from. If Lisa's still in here, maybe she can provide a link. So Lisa, please, if you're still in here, if you can add a link to Pastor John, Brother John's Discord server, that would be great to grow the server. That would be awesome there to help continue to grow that. If you wouldn't mind, or if you can, post that link on here. So this is in case people who haven't joined the server yet can join the server. And there's a lot of cool things to do on Brother John's server. Everything from main topic to off topic to media to posting pictures of pets, music, things of that nature. So it's a lot of great stuff. Libby says Mr. McKinney knew where to set up for today. Yes, I think, yep, he did. Yep, for sure. If he's headed to Iowa, he is most likely in the right spot right now. Um, and thank you. I must mention, thank you to Heidi for subscribing. Very awesome for you to subscribe. Thank you so much, Heidi, for the encouragement and for just trusting in me to provide you with great information. And as you can see, it looks like I'm at 2,150. So I'm making my way quickly again because of you guys to 2,200 subscribers. So very thankful for that. And I have to point out that brother John did cross over the 50,000 mark subscribers last night. So very happy, very blessed that happened to him. Um, that he's at 50,000 now. So very thankful that he's at over 50,000. So very thankful for that. Very blessed that he is over that mark. 50,000 is a great mark. That shows a lot of growth on and a lot of trust. So definitely so. So it's very good. Let me go. Looks like we got Michael in here. Aloha, Michael. Great to see you. Very thankful that you are here, brother. Um, so very thankful that you are here again. Michael from Hawaii. So aloha, brother Michael, from there. Let's see. Debbie says, yes, it does, Libby. That's how John got his truck windshield cracked. And then looks like let's see. Oh, I went way up. My bad. Don't know what happened. Okay. It looks like yes. So yes, everybody say hi to Michael, please. So I went too high up on that. And Julie says, okay, this is what I saw. Julie says, as I have this stream on my phone, I have on Fox Weather on the living room TV. Awesome. Thank you, Julie. Fox Weather is, I have watched some of their stuff before too. They have pretty good stuff there as well. And obviously, the way I tell people is, is watch whatever you feel gives you the most trusted, most complete forecast or complete wherever you get the most satisfaction from and you feel that you get the best knowledge from. So whether that's Fox Weather or that's your local weather person or your local somebody, Ryan Hall or Max Velocity or, Cruz Haynes or, whomever it is, whomever you feel comfortable and feel like you get the best information from, stick with them. And, so yeah, but great stuff. Definitely. Thank you. Thank you so much for that, Julie. Appreciate that. Yes, looks like Michael is. It's definitely the morning over there for Michael. So Michael is probably just waking up, possibly, or getting uh, whatever. But anyways, it's definitely the morning time over there in Hawaii. So, and Michael, if you will, please let us know which island you are from in Hawaii. Which island are you on? Oahu or, whatever that may be. Which island are you happen to be on? So that'd be pretty cool. And a pretty cool thing about Hawaii, if you guys don't know, if you guys weren't uh, watching recently, there is a lady uh, uh, who just became the fastest individual, man or woman, to row from California to Hawaii. Uh, and she goes by Euro Kelsey on Facebook. So that was a pretty cool feat. Pretty awesome. She spent, I think it was 40, a little over 40, like 43 days, I believe, out in sea. So could you imagine being how lonely that would be in the middle of the Pacific Ocean, just you on a very tiny rowboat going from California to Hawaii. So great accomplishment for her for that. But and Michael says he is from Oahu, which is awesome. Very cool, brother. Uh, and then I believe Julie said, yes, there is something for everyone. But again, pretty cool thing about Hawaii, she ended up, I believe she ended up on, I can't remember which island she ended up rowing to. I thought it was Oahu. I could be wrong when it comes to that. But nonetheless, pretty cool feat. So imagine being out there, just you, a small, tiny dot on the map in the middle of the largest ocean in the world. Very cool accomplishment. So again, she goes by Euro Kelsey on Facebook. Don't know if she has a YouTube or not. I just was following her and watching it on Facebook. So, but cool stuff when it comes to that. So, but very great that that's very great that um, you know is very thankful for all of you. Very thankful again for everything that you guys are, everything that you guys do, for believing in me, for trusting in me, for enjoying these, learning about these topics, and for just hanging out and having fun, and but again, I'm open for request. I am open for feedback. I am open for any of that stuff. So it's great to sharpen each other and get better at what we do. So very thankful, very blessed, very honored, um, because of all of you. And thank you to Horatio for subscribing. Thank you, Horatio Lopez. You are awesome. Thank you for coming in here and subscribing. And today, thank you. You guys are, again, so awesome. And again, it doesn't matter if I have 1,000 people watching or if I have 0 people watching. Um, I'm still going to do what I love to do, and hopefully, you guys will join me on my journey to reach as many people as possible. So, you guys, you guys are awesome when it comes to questions. When you guys come to moderating, when it comes to just being awesome, you guys are that. And when I say awesome, I don't just mean that you guys. I mean that like lightly. Uh, I mean that from the bottom of my heart. You guys are very, very awesome. Because again, I am very, very aware that you could spend your time doing anything else besides listening to me talk about weather and talk about other stuff and teach you guys about this stuff. You guys could be doing everything else, but you choose to be here and choose to support me and choose to be in my streams. So again, I know the time that it takes. I know the um, the energy that it takes. I know all that it does to do that, and I'm very thankful for that. And I definitely do not take that for granted, because time is obviously something that we cannot ever get back. So that is um, so that is just sincere, grateful gratitude towards all of you. You guys are just very a part of such a great family. And again, we are all brought together, thankfully, because of Pastor John and being a part of his streams. So again, he's brought a lot of us together, which is amazing and absolutely just totally awesome. So when it comes to that, so Debbie says that's why we are here, John Boy. Thank you so much, Debbie. Uh, you are a tremendous supporter, a tremendous, um, just a tremendous encourager. And Monk says, it's a joy to listen to you teach. Thank you, Monk. Very cool for that. Just thankful that you get some fulfillment out of that. You get some sort of teaching, some sort of I try not to make my teachings very deep or anything like that. I try to keep it at a level that we all can keep it. I try to keep it as simplistic as possible, but still also to where you retain enough information to to understand that. So, but yeah, it's so it's pretty. It's so I try to do that. I try to keep it simple. That's my method. Is a KIS method. Uh, but again, you know, I'm very thankful that you guys are here for all of that and hearing all that. I just saw somebody else come in with something in chat. Let me look at that real quick. Libby says, "Congrats on over 60 new subs. Thank you." Yes. Very blessed. I don't even really know what this. I don't even have words. Like honestly, like I never thought I would be almost at 2.2K subscribers, and I don't know. I've only This is only my ninth stream, So uh, I never thought I would. I'm just blessed. I'm blessed, and I'm humble. So uh, I just, as I know that it all can be, it just very thankful. Again, I don't even have a lot of words to say about it because I'm just so blown away by the support and of everybody, and I'm blown away by the support of my mental illness crisis video that I made. I mean, I got last time I checked, that's got like 14,000 views or more. So for that to be exploding is just phenomenal. So hopefully that's reaching people out there. Hopefully that is helping people out there. Hopefully, um, people are being able to learn that they're and see that they're not alone in certain instances like that, and that we all face different crises, and that we all sometimes face the same crisis, um, so just very thankful and blessed that has blown up the way that it has blown up, and so just very thankful for all that, and just thankful for all of you. Again, hopefully you guys enjoyed the topic. Hopefully you guys enjoyed learning about that. We'll be ending my stream here in about 5 minutes. So, again, just so thankful, so blessed, uh, just for a great time. But again, if you have any requests, any type of anything you want to learn about, or anything like that, and if I know it enough to teach it, and if I can obviously spend the time researching on it and learn it, it is something I would definitely love to do and teach back. So um, I'm going to also be looking at getting involving more games. Like I'm looking at to see if I can involve like some sort of like trivia games, like when it comes to like tornadoes or severe weather, just something that we can play inside of the chat as well, and to be able to kind of just um, to kind of be active that way. So I think cool trivia game would be kind of cool to have about severe weather or tornadoes themselves. Libby says it's humbling when God blesses us. He is using you and blessing you as you continue following. Yes, thank you, Libby. I appreciate that. It is very humbling. It's very it's just it's like an awe-inspiring type type of thing. So it's just very awesome when it comes to that. Yes, very humbled because I know I just am very thankful for that. But yeah, so I think trivia would be cool. To have like some sort of trivia game that you guys can just do a trivia. Maybe we can do trivia with with myself as well, but definitely amongst each other or something. That would be cool. Oh, I must say thank you. I'm probably gonna pronounce that wrong. Uh, is it Paola? Paolo? I don't. I am sorry. I can't. Uh, but nonetheless, Diaz. I can see it as a last name. Thank you so much for subscribing. Very thankful and very blessed for your subscription, and very blessed for your belief and faith in me. But yes, definitely, I think trivia would be fun. I think some sort of maybe some game like that. But I'm definitely looking into adding that in to where it keeps this a little bit more engaged in that process, and just to kind of because I do know that sometimes sitting there on the phone and or your computer or wherever else, I do know it can get sometimes you know mundane at times and whatnot. So no matter who's talking or no matter who's whatever. So for you guys to invest that time in me, I need to invest time with you guys, and keep you guys active and out there so as well. But yeah, very thankful. Like I said, very thankful for all that. Very thankful for all of you. Very thankful. Just blessed, honored. Again through all of your guys' support and everything else that comes to that. So again, I'm at a loss for words on a lot of that. All I can say is that I'm very blessed. I'm you all are brothers and sisters in Christ to me. And again, my overarching goal is to again spread the gospel as much as I can through across as many platforms as possible. I know that a lot of people Some people don't like that, and some people don't want to hear that. But again, I am bold for Christ. I am unashamed. I'm unapologetic when it comes to being bold for Christ. So, um, but again, I am just a flawed sinner. I am um, just trying. I shouldn't say trying because, but I should say doing my best to do that. So, very thankful for that. But yes, again, please reach out if you have any, requests, anything you want to learn about. But let me know, about stream. Thankful for all of you, and I look forward to seeing you guys later today in Brother John's stream. So, Pastor John, I'm sure we'll have a great stream. He will have a great storm chase. I look forward to seeing all of you there. And if there are people in here who are not followers um, of Pastor John, uh, let me see if I type it in here if it pops up. So, see here. Should be able to follow. Let's see if it comes up through. Let me see. I might have to go to. Oh, there it is. So there you go. There is a link to Papa John, as he's called, as known as well. So you can click on the link there if you're not a subscriber to uh, Brother John. You can click on his link there and please subscribe to his YouTube channel. So thank you so much for that. Uh, Libby says, striving to be all he wants us to be, trusting him to reveal where we need to follow him better. Yes. Thank you, Libby, for that. Thank you, Libby. Very, very great words. Very great words of inspiration, encouragement. Thank you so much, Libby. You are definitely a dear sister in Christ. Definitely so. Um, but yeah, definitely. And I'll also say too, if you are not a subscriber of Papa John's son, Freddie, uh, please subscribe to Freddie as well. So anytime you want to see Freddie's link, all you have to do is type in the exclamation point like you'll see me do, and then type in exclamation point Freddie. And I typed it wrong, so never mind. Let me type it again. Let me type it better this time, and let me type it up there. So as you can see, there is Freddie's um, that is Freddie's YouTube channel. So if you haven't yet, you can subscribe. If you type in like that, like I typed in, uh, exclamation point Freddie like that, his YouTube channel will pop up. So definitely shouting out Freddie all the time, shouting out Brother John all the time. So just ways to to help people. And so again, if you are not a subscriber of them, please click on their links and subscribe to them because they offer great content. And if you don't know who they are, John McKinney is Freddie McKinney's father. So it is a father and son out there storm chasing. Sometimes they do some father and son storm chasing together. But lately it's been separate. But nonetheless, they do sometimes do some streams together, some storm chasing together. So pretty cool stuff when it comes to that. And if you ever want to know the outlook for the SPC, you can also type in exclamation point outlook. Type that in, and that's going to bring up the SPC outlook. So as you see that, you can click on that, and that will give you the SPC outlook for the day if you ever want to see that while you are in here. So very, very cool stuff. But also the most important one that I want to show you guys real quick before I end the stream is if you type in exclamation point Bible, it will take you to Bible.com. So if you type in again exclamation point Bible, it will take you to Bible.com. So, which is a great, obviously a great start, a great place if you ever want to read the Bible online. So, again, you can always type in exclamation point Bible to get to that. So it's very, very awesome. Libby says, I enjoy witnessing their father son relationship. The respect they have for each other is sadly rare in our world. Yes, definitely. Uh, definitely, Libby. Um, Unfortunately, it is, yes. Uh, so very respectable. Uh, so very, yes, very respectable to that. And yes, so thank you, Libby, for that. Highly into and very, very encouraged by the relationship. And it looks like I just missed somebody here. Who was it? Oh, Julie. Thank you, Julie. Julie says, and W. Freddie, the McKinneys are good people and good chasers. Yes, definitely agree with that 100% when it comes to that, for sure. But again, you can use those. You all have the option to use those types of commands. So you can use the exclamation point Freddy, exclamation point Papa John, exclamation point Outlook. You can do that. And exclamation point Bible. If you want to, read the Bible online, if you want to get more information on that. But again, point you in the right direction. So, but there's a lot of cool features that I am still working on adding in to that. So, still working a little bit on the overlay, things like that. But again, very, very gracious and very thankful for all of you. So, again, I look forward to seeing all of you a little bit later here. Again, I do believe, and as mentioned by Debbie, that Papa John will be streaming sometime today. Very thankful for that. Looking forward to that, to seeing him do that. So, again, I look forward to seeing all of you great people in there. All of you in there are awesome. And again, I'm looking forward to seeing everybody in there. Thank you again for being here. Thank you for everybody who has tuned in, listened to me ramble on about weather and some other things. So thank you for being there and listening to that. I appreciate you listening to me ramble on for been streaming now for over 4.5 hours. So, but it's been a great stream. It's been a great morning. It's been a great afternoon. It's just been a great time because you guys all make it great. So, again, you guys are awesome. Looking forward to seeing you guys later. Again, reach out if you have any type of questions, any type of anything, request, feedback, anything like that. It is all welcomed. So again, yes, thank you, Libby. Thank you, Debbie. Thank you, everybody who has chimed in. Thank everybody who is listening. Thank you, everybody, for just being here, and for the people who have just been lurking. Thank you for lurking. Thank you for being part of the audience as well. So definitely thankful for that. So thankful for all of you. You all are amazing, like I've said. Looking forward to seeing all of you later today in Papa John's stream. So, and as always,